Hello,
Hello, hello.
hello. Hello, working sir. Hello? It's a muted. Unmute कर दी. हाँ हाँ. Unmute है. A very good morning to everybody. It's my pleasure to welcome all the dignitaries, organizers, researchers, academicians, and participants to the International Conference on Artificial Intelligence and Data Science. I'm Swati Gauroju on behalf of Sreyas Institute of Engineering and Technology. Would like to extend a very warm welcome to all of you. We are proud to have you here all in the Conference of Artificial Intelligence and Data Science Technology Fraternity. ICAIDS has a unique distinction of bringing together such a large number of research works around the world for a vibrant and intense exchange of views, knowledge, and experience on minutiae of technology spread. Firstly, at the outset, I would like to welcome our respected governing body, Chairman Shri Anantala Vinay Kumar Reddy Garu, Secretary Shri Chintala Ravindranath Yadav Garu, CEO and Treasurer Shri N. Sharat Reddy Garu, our dynamic Vice Chairman Shri Anantala Hriday Reddy Garu, our respected principal, Dr. S. Sai Satyanarayana Reddy Garu, our honored academic dean, Dr. Sri Hari Garu, the head of the CSE department, Dr. Sheikh Abdul Nabi Garu, head of the AI&ML department and general chair of ICAIDS, Dr. Ashwini Kumar Garu, head of the DS department, Dr. Jairam Garu, head of the ECE department, Sri B. Srinivas Garu, head of the mechanical department, Dr. P. Maheshwar Garu, head of the civil department, Dr. K. Sridhar Reddy Garu, head of the HNDS department, Sri Nasiruddin Garu, and the program convener, Dr. V. Biksham Garu, to the inaugural ceremony. I request our honorable dignitaries, Principal Sir, Vice Chairman Sir, Suresh Akela Sir, to come onto the dais and occupy the seats on the dais. I request Siri to present the bouquets to Principal Sir and Suresh Akela Sir. Thank you, Siri. I request our academic dean, Dr. Srihari Sir, Dean R&D, Dr. Suresh Akela Sir, General Chair, Dr. Ashwini Kumar Sir, DS HOD, Dr. Jairam Sir, HOD CSC, Dr. Abdul Nabi Sir, and the convener, Dr. Biksham Sir, to come on to the dais. And IQAC Director Panduranga Rao Sir, to please come on to the dais. Please sit. Thank you, sir. Now I request our conference general chair, Dr. Ashwini Kumar Sir, to read the conference report.
Thank you, ma'am. Good morning, everyone. A warm welcome to opening ceremony of International Conference of Artificial Intelligence and Data Science 2022. This is Dr. Ashwini Kumar, General Chair of the conference and Head Department of CSE AI&ML at Sreyas Institute of Engineering Technology, Hyderabad. First of all, I would like to welcome our Honorable Chief Guest, Professor Gautam Mahapatra Sir, who is the Vice President of Computer Society of India, who has accepted our invitation to be a Chief Guest for this conference. I also welcome our Chief Patron and Chairman, Sri Anantala Vinay Kumar Reddy Sir, Chief Patron and Secretary, Sri Chintala Ravindra Yadav Sir, Chief Patron and CEO, Sri Sharath Reddy Sir, Chief Patron and our young Vice Chairman Sir, Sri Hridar Reddy Sir, Patron and Program Chair, Professor Dr. Sai Satyanarayana Reddy Sir, who is a Principal and leading the institute from the front, our TPC Chair, Professor Pradeep Kumar Gupta Sir, and Professor Mayank Singh. I would also like to welcome our eminent keynote speakers, Professor Justin Zhang from University of Florida, USA, Professor John, Head of the Department PMDM, France, Professor Mohammad Usman from King Khalid University, Saudi Arabia, Dr. Pradeep Kumar Gupta from JP University of Information Technology, India, Professor Dr. Pfister from University of Maribor, Slovenia. I welcome all the deans, HODs, front of the examination, faculty members, students, and my dear colleagues. A very good morning to all the participants from various time zones and warm welcome to the opening ceremony of the first International Conference on Artificial Intelligence Data Science, ICAIDS-2022 once again. This conference is technically sponsored by Computer Society of India and financially supported by the management of Sreyas Institute of Engineering Technology, Hyderabad. ICAIDS-2022 was planned to be held in offline mode, but due to the COVID situation, we are meeting virtually today from all the participants. The main objective of this conference is to provide a common platform for the active researchers and industry experts across the globe who are working in the machine learning, natural language processing, robotics, and data science, or using these techniques for their research work. I'm happy to share that ICAIDS 2022 has received tremendous response around the globe. We have totally received 195 paper submission, and the website of ICAIDS 2022 2022 was visited by more than 2,000 visitors from 53 different countries. After the initial assessment of the submitted paper, we have conducted double-blind review by our technical program committee members of ICAIDS-2022, and they are total 119 academics from the different universities who has supported us for reviewing these papers. After rigorous review process and rigorous recommendation, we have accepted 44 papers for the final presentation and for further possible publication at Springer CCIS series, which is Scopus Index. I proudly announce that the acceptance ratio of the conference is about 22%, and the credit to maintain this quality of the conference goes to the technical program committee chairs, organizing chairs, reviewers, and various TPC member of ICAIDS 2022. Geographically, at international level, we have received paper from Ethiopia, United States of Africa, Bangladesh, Canada, Philippines, Ukraine, Iran, Tirana, South Korea, Russia, Germany, and Iran. From India, we have received the paper almost from all the states ranging from Tamil Nadu, Andhra Pradesh, West Bengal, Karnataka, Uttar Pradesh, Madhya Pradesh, Punjab, and other states. So keeping these facts in mind, we are hopeful that this conference will have a good mixture of researchers from different background and technical levels. It will provide the researchers a great forum to interact, to share, to discuss, to showcase their research activities. They can take some good ideas to enhance their research work and can provide some solution for the betterment of the society. We are fortunate enough to have a very eminent personalities as a speaker for delivering the keynote addresses and invited talks. I am sure that these talks will be very helpful and will help us in understanding the emerging computing techniques in detail and will open a new research area for the researchers. I'm extremely grateful and thankful to all the members of various committees of ICAIDS 2022 who is directly and indirectly connected to us for their support. It was not possible without their support to conduct such an international conference. I once again welcome you all and wish you a very happy, pleasant, and knowledge-sharing sessions ahead for these next 2 days. Thank you all.
Thank you very much, sir. Now, may I invite our Honorable Vice Chairman, Shri Anantala Hriday Reddy, sir, to the platform, and I request sir to speak few words upon the occasion. We are sorry, actually, due to some technical issues, sir is unable to join the meeting. Now, on behalf of the Sreyas Institute of Engineering and Technology, I take the honor of inviting our chief guest, Dr. Gautam Mahapatra, sir, to the event. Dr. Gautam Mahapatra, sir, is the scientist GET RDO and Fellow of Computer Society of India. Sir completed his MSc in 1991 from Indian Institute of Technology, Dhanbad, and he won the President Gold Medal. He completed his MBA in Systems and Technology Management in the year 2002 from BIM and ITM. Shri Gautam Mahapatra has 25 plus years of research and project implementation experience in the field of IT and the computer science in defense and R&D organizations. In defense R&D, under his leadership, there were several implementations that were made, such as enterprise class IT applications along with ERP, PLM, e-governance, e-procurement, e-imports, e-analytics, big data, and DSS, which have been running successfully. There were 23 awards and others received by Sir. He is the member of 8 well-known organizations such as Computer Society of India, Industry Institute Interaction Cell, LASSIB Society, Cryptology Research Society of India, SAP Community Network, etc. In past 25 years, about 40 plus technical reports.
All spheres of life, be it governance, be it services or security or economy, are being increasingly digitized and IT enabled day by day. In fact, digitization of financial system in our country is happening in the rapid space. During COVID, India stood fast for doing the highest number of real-time online transactions ahead of China and the US. Nowadays, even we see battlefields are increasingly being digitized. It is pretty evident that the fusion of AI with defense hardware and software enhances the military capability. AI is a force multiplier for defense. AI-based swarm intelligence capable drone systems changing the face of the warfare. AI-based software-controlled drone technology is being used for precision attack in ongoing Ukraine and Russian conflict. AI eventually manifests in all dimensions of warfare, starting from military equipment and platform, combat simulation and training, mission planning, decision making, target recognition, threat monitoring, situational awareness, and cyber warfare. We are adopting digitization at a very high speed, almost in every aspect of life. As a result, there is a tremendous digital shift in our country and worldwide. Consequently, we are also increasingly exposed to the cyber threats. That is, our attack surface area is also increasing. So most of the future wars will be fought in cyberspace. Now the question is how to make our country cyber safe so that our network critical infrastructure can endure a constant barrage of cyber attack. AI can be a really great help to fight cyber wars. Days to come, artificial intelligence is expected to become a significant technology in every aspect of our life. Today, the amount of data that is generated by both human and machines are far outpace human ability to absorb, interpret, and make complex decisions based on that data. As a result, artificial intelligence will be the basis for all computer learning and is the future of all complex decision making. Hence, our students will have great employability in the field of AI. But a word of caution about the flip side of AI, that is AI biases. Mimicking the existing AI technology which has been developed elsewhere in the world for a country like India can be a disastrous impact. With rapid adoption of AI across variety of sectors, including in areas such as justice and healthcare, technologists and policymakers have raised concern about the lack of accountability and biases associated with AI-based decisions. Various case studies regarding AI biases are now available in the public domain. So we should look into the challenges of new perspective like the sources of AI biases, detection of biases, and implementing the best practices such as man-in-the-loop, audit, etc. Secondly, data science looks for the pattern in data to make well-informed decisions. Dear student, if you want to become data scientist, you need to have both technical as well as non-technical human skill. Among the technical skill, the following are essential. Statistics and probability skill, which are fundamental. Then come mathematical skill like calculus, linear algebra, discrete mathematics, optimization theory. Programming skill like Python, R, Pandas. Database query languages like SQL and NoSQL languages. Big data technologies like Hadoop, Apache Spark, etc. Among the non-technical skills, I'd like to mention you should have love for data. Because data is now a new form of currency. then you should have the domain knowledge where you are working. You must be a team player and you should have great communication skill. The purpose of data science is to extract, pre-process and analyze data. But the data scientist role is not only limited to statistical processing of data alone, but also managing and communicating data to help companies to make better decisions. AI and data science are becoming dominant technology because of the digital revolution. If you analyze the driver of digital revolution, you will undoubtedly observe that the young population is the main contributor to it. The young generation depends on cutting edge, automated, quicker and efficient technology and services. In my opinion, India has a great potential for developing the industry for AI and data sciences as the youngest nation globally. So young generation and student community to be more involved by the industry to develop AI and data science product. Today, CSI has the highest reach to the student community in India. CSI has 75 plus student branches across India. One of the significant constraints of developing AI and data science based industries is the shortage of a trained workforce. Industry can collaborate with CSI to have access to a large pool of excellent student resources who are trained to meet the industry requirement. Atmanirbhar Bharat is not a choice anymore, but it is an inevitable reality. It has to become a strategic necessity in the critical technology sector. CSI is planning to establish a working group on AI to encourage, motivate and train students and professionals in AI. I sincerely thank the sponsors. With their kind support, this event was possible to organize. I want to mention my favorite quote of Dr. APJ Kalam, Missile Man of India and former most popular President of India, for my student friends. I quote, if four things are followed, having a great aim, acquiring knowledge, hard work and perseverance, then anything can be achieved. With this, I log off. I wish you all a very extraordinary conference. Jai Hind.
Thank you, sir. That was really informative session that you have given. It was really a wonderful talk, sir. We definitely remember and try to implement it in our work. Now, I request all the dignitaries, guests, authors, and faculty to take a short break of 10 minutes, after which at around 10:35 sharp, the session 1 is going to begin. I request all the participants and authors to join back with the provided link in the sharp 10:35 a.m.
Hello, Swati ma'am, can you hear me? Madam. Hello, Swati ma'am, can you hear me?
Yes, sir. Yes, sir. I can hear you now.
Yeah. So just check, madam, session chairs are ready. Madam Soumi Datta madam is there, right?
Okay.
And then you just start the session, madam.
Okay, sir. Sure.
Right.
Firstly, let us check whether, sir, okay. Welcome back. We are glad to hear again to this conference. We are glad to have the session chairs, Dr. Soumi Datta from Institute of Engineering and Management, Kolkata, Dr. Gautam Kumar from CMR Engineering College, Dr. S. Venkatachitra from Sreyas Institute of Engineering and Technology, Hyderabad, and Professor Jitendra Kumar Seth from KIAT UP. We welcome you all here, sir. With your permission, we would like to start the session, sir. Is it okay?
Yes, madam. Go ahead, madam.
Okay.
Soumi Datta madam, can you hear me? I'll make a co-host.
Yes, I can listen. Actually, I couldn't unmute myself. It's fine.
Right. Can we start, madam?
Yes.
Sure. Okay. Madam, please call the first participant.
Yes, sir.
Right.
May I know paper ID 2, Ashraf Aslam is here? Ashraf Aslam? Sir,
he's there, madam. Ashraf is there in a meeting.
Yes, sir. He's there, but asked to unmute. Can he unmute himself, sir?
Okay, I'll make him as a... He can unmute, madam, no issue.
Okay. Ashraf Aslam, can you hear me?
Hello. Okay.
Yes.
I tried initially. I was unable to unmute. Yeah.
Okay. I think now this is fine, I guess so, right?
Yes. Now it's...
Yes. Sir, your time is only for 12 minutes you can present, and after that, 3 minutes will be given for queries. We request you to wind up your presentation in stipulated time, sir. Thank you.
Sure, ma'am.
Yeah. Please share your screen also.
Okay. Yeah. It says that unless the other person stops sharing their screen, only then I can share my screen.
Okay, right. I have stopped the sharing.
Okay, sir. Let me do that. Yes. Is it visible, sir?
Yeah, it is visible.
So, yeah. A very warm welcome to all the dignitaries present here. I'm Ashraf Alam from IIT Kharagpur. The topic of my paper is cloud-based e-learning, development of conceptual model for adaptive e-learning ecosystem based on cloud computing infrastructure. The purpose of this article is to discuss researches done on the efficacy of cloud computing in e-learning. It summarizes the present state of cloud computing e-learning and the consequences for educators. Thus, the article begins with an overview of e-learning and cloud computing architectures and a discussion of their key characteristics. The article further discusses the potential challenges associated with implementing e-learning systems. The benefits of cloud computing are promoted as a possible solution to these issues in my paper. Additionally, there are answers to problems that arise when e-learning makes use of cloud computing, as well as an overview of most commonly used architectural design patterns of cloud computing e-learning. Cloud computing based e-learning. Additionally, the challenges associated with implementing cloud-based e-learning systems and potential solutions are discussed. This article further proposes a paradigmatic model for cloud-based e-learning. The model is created using diffusion of innovation and fit viability model along with factors influencing information culture. The principal objective of the proposed model is to discover the most important variables that influence cloud computing for the purpose of improving e-learning. Now, starting with the introduction here, you can see the technological advances in modern information and communication technologies heralded a period of unprecedented societal upheaval at the turn of the 20th century. Cloud computing has emerged as a cutting-edge technology in recent years, accelerating the pace of educational innovation. Thus, cloud computing seems to be an optimal solution for sustaining the functioning of e-learning system while incorporating cutting-edge multimedia and communication technologies. Cloud computing is an excellent technology for academic institutions and other resource-constrained organizations to host and run online learning systems. Given the ubiquitous use of computers in educational institutions, as well as the rapid development of technology, there is tremendous potential to promote and create new learning cultures. Moving ahead, by integrating the linkage and linking incongruent technologies such as cloud computing and grid computing, it is possible to fully integrate and connect the physical environment, information space, and human civilization. For example, cloud computing enables students to seek expertise, knowledge, and talent from academic experts regardless of their physical location. The term situated learning in cloud computing parlance refers to a continuous and critical as well as cyclical process in which each context of action generates new meaning. This does not imply that the learner creates a collection of mental representations or self-contained structures during the process. While incorporating cloud computing into e-learning services has many advantages, there are certain risks and challenges to consider, including cost, bandwidth, security, user concept, forms and methods, as well as management duties and resources. Due to the virtualization of these resources, edtech companies, students, and universities may also lease them. Cloud computing's autonomous, cost-effective, flexible, and reliable infrastructure enables the creation of an e-learning ecosystem. Cloud computing has been enabled by improving program designs, quickly developing technological standards, and ubiquitous internet use. Moving on, Google anticipates a massive migration of services and software to the cloud. The ease with which business may use the cloud model's economic advantage shows cloud computing's fast development. We are today controlled by economic paradigm that enables the cloud to flourish. E-learning has been recognized as a critical component of a long-term organizational performance and as a major indicator of an organization's efficiency, creative capability, and potential to grow in a competitive environment characterized by globalization, growing complexity, and rapid change. It has established itself as a new paradigmatic model in modern education, fundamentally altering our conception of learning. Cloud computing and related concepts such as mobile cloud computing has altered the educational environment in recent years as a result of e-learning technologies. Lastly, mobile technologies, authoring tools, and digital instructional games, virtual simulations are only some of the advancements in e-learning technology. Moving ahead, talking about advantages of cloud computing adoption for e-learning solutions, many educational institutions lack the resources and infrastructure necessary to operate or install an e-learning system. That we can see often in our country as well. There are several small engineering colleges where there are no infrastructure. Similarly, cloud computing-based e-learning systems provide many advantages over on-premise e-learning systems, some of which include the price is competitive, software updates are completed in a matter of seconds, added layer of security for cloud-based e-learning systems, enhances overall performance and productivity of professors and students, enable real-time collaboration among distant team members, revised version is more compatible with the document types, no in-house IT assistance is needed, and assists in retaining current faculty base. Talking about benefits, there are many benefits for students as well. Pupils can enroll in online distance learning ODL programs. They can send activities, projects, and tasks from home, can send feedback and take examinations at the comfort of their home. Talking about the advantages for educators, those include content management, communication with pupils via forums, test preparation, evaluation of tests, grading of students, homework or assignment, and projects, and sending of feedback. Coming to the conceptual model and research hypothesis, The main aim of this study is to develop a model of higher education institutions' usage of cloud computing based e-learning technologies with a focus on internal organizational factors that impact its adoption. Based on the approach outlined in this study, the researcher has looked forward to find internal organizational factors that contribute to the fast adoption of cloud-based e-learning in higher educational institutions. The proposed research paradigm is based on the information culture diffusion of innovation theory, that is DIT, and fit viability model. It discusses how cloud-based e-learning is compatible with the unique requirements of higher educational institutions as defined by fit viability model. The findings show that fit metric evaluates how well new applications fit inside the organization's core capabilities, structures, values, and cultures. The effectiveness of cloud-based e-learning may be quantified using Rogers' DOI principle of relative advantage, complexity, and compatibility. The DOI hypothesis states that a development's relative worth is greater than that of its predecessors. Also, cloud-based e-learning enables higher education institutions to increase their data storage capacity and to provide students with access to any app or broadband internet from any device and location. The complexity of how difficult it is to utilize or acquire innovation and sustainability reduces obstacles for educational institutions and information technology executives, making cloud computing electronic training platforms ideal for providing high quality academic services. However, when it comes to transferring different interfaces and data to the cloud, the proposed model shows the compatibility of technology and its appropriateness for higher education institutions. Additionally, viability is critical since it is utilized to determine if new applications are required and capable of delivering value. The suggested conceptual model's second component is information culture, which focuses on qualities such as information integrity, formality, control, and responsiveness. As a result, cloud-based e-learning is widely recognized in higher educational institutions, which contributes substantially to the model's adoption. Information integrity refers to the reliability and trustworthiness of data in cloud computing technologies, as well as correction of errors or concerns regarding student or employee security. Information control is synonymous with data control and refers to specific techniques of data usage that are designed to avoid or encourage certain behaviors. However, data control and information control are mutually exclusive concepts. Decision makers may monitor and control operational maneuvers by using data collected from a variety of sources. Talking about quickly about the cloud-based e-learning architecture. The cloud-based e-learning architecture system is divided into 5 layers.
Excuse me, Ashraf, can you hear me?
Yes, I can hear
Ashraf,
you.
there is only 1 minute left for your PPT.
Yes, I'll be concluding in 1 minute. Yes, ma'am. So cloud-based e-learning architecture is divided into 5 layers: infrastructure layer, software layer, resource management layer, service layer, and application layer. The components of the proposed cloud-based e-learning architecture may be classified on a number of levels. The infrastructure level is made up of a collection of scalable and dynamic physical hosts. On this second layer, a standardized interface is accessible to all e-learning developers. At the system level, resource management guarantees the independence of hardware and software resources. The service layer includes a variety of well-known cloud services. Cloud computing services include cloud-based and platform-based software services. This is the last slide, ma'am. So yeah, along with administrative and assessment functions, the application layer provides collaboration capabilities such as virtual lab and the ability to share and create content. Students and educational institutions may lease virtualized educational resources for e-learning from cloud providers, which they can then rent to other students and educational institutions. The hardware resource layer is responsible for managing the computer's fundamental components, such as CPU and physical memory. This layer of e-learning development is critical to the overall system design. A software resource layer is constructed and supplied with assistance of middleware and operating systems. Software developers have a plethora of choice for developing e-learning system applications. The application layer outlines the development of many e-learning components and serves as the primary business case for e-learning. This layer primarily assists in administrative educational activities such as teacher evaluation and platform development, as well as content distribution and production. And because of paucity of time, I would that was kind of like an overview of the e-learning architecture that is proposed. Yeah, these are the list of few of the references that I've used. And thank you so much for your patient listening. Thank you.
Thank you, Ashraf. Ma'am, can you, do you have any queries? Good morning, sir. Achitraf, sir.
No,
Sir,
no queries. Well presentation. No queries from my side. Very good model proposed.
Thank you, ma'am.
Sir, your voice is not audible, sir. Achitraf, sir, your voice is not audible.
Important part to it. Here, the author have used the ABC as the optimizer to rightly predict the the ground vibration of those mining pits. Similarly, Zhang and its own associated author scholars, they have used differential equation to optimize and a fast forward network. And so what is done here, that here they created a model now to solve the problem related to retaining walls in the geotechnics. So in the geotechnics, there are the walls that walls we are called RW, that is retaining walls. It has got different parameters. Parameters are like friction angle, wall thickness, height of the wall, and many of things. The right constitute of those parameter value that gives rise to a better RWs. Here, Zhang and their scholars, they have studied 2,800 similar RW. They produce the whole data, utilize feed forward network or fast forward network along with the differential evolution, that is D as an optimizer to optimize those. Similarly, if you see like in a Gupta and the scholars, they apply the equilibrium optimizer with mutation strategy for solving couple of numerical optimization problems as well. If I go to the conclusions, so we have attempted an analytical review of the optimization technique that can be used for the object image operations. The computer vision task that has been used in the multiple traditional applications, which related to the automation process and all, and it has got multiple benefits both in science and engineering. So though we have our goal was to talk about or so that many optimization strategies can be used, but the meta heuristic part has been less used, but can be used because of the wide variety of the population, and hence a better a better a better chance of getting a minimal or optimal or optima and the minimum. So we can the we have showed a few of the variants of optimization technique. There is still an option of work in this meta heuristic area. We can opt and implement new optimization technique that can be used to enhance the solution, and this optimization technique can better provide a better fitness value, less computational burden, as well as it can give a better convergence profile. With that, thank you so much. Please let me know if you have got any query or question for me. Thank you.
Dear session chair, now I would like to ask you to ask a question if you have any questions.
Ashwini sir?
Yes, sir, I can hear you.
Yeah. Rajesh Kumarji, good explanation. Your problem definition is so nice. I would like to recommend you, there are few challenges in CNN, especially overfitting, and one more is a class imbalance, and there are exploring gradient. These three are the major challenges.
Right, sir.
Okay. You please concentrate when you choose parameters. at a particular data set to reach your vision. Okay. Yeah. In what, how do you overcome these problems, sir?
So that is what, like, in the gradient based, as I told, like gradient based already has the issues we have seen of overfitting or underfitting. And if we choose the meta heuristic of algorithm, because of it is a population based, so therefore there are multiple populations around. Hence, we are better equipped to handle this situation, because we should be able to get a right minima and the right maxima. And that was the reason, sir, that instead of gradient based, like GCD or something, the proposal is to start seeing an optimizer which are meta heuristic or population based in nature. I hope that I am able to answer your question.
Yeah, exactly. You're on the line, and also your explanation is nice, so that you can get a good fitness value to reach that accuracy.
That's right, sir. And that way we can adjust our weight and bias in a better way than going for with the gradient based.
Yes, thank you, sir.
Thank you.
Okay, I have a question that you have used CNN. Why CNN? Why deep learning? What is the advantage you find in machine learning, general machine learning, that you have moved to the deep learning part?
Yes, ma'am. So if you see, like, in normal, if I if I talk about the image processing, what we are talking about is we are dealing with pixels. And now even a small picture may have thousands of different pixels to separate it out. By using CNN, what we are doing, using the multiple layers like poolings, normalization, all, what we are doing, we are only extracting the right pixels and the meaningful pixel, which is helping us reduce the overall burden of processing time.
Thank you, sir. Any other questions, ma'am?
No question.
Mr. Rajesh, I have a question. You have shown us meta heuristic is doing good with the CNN for object identification. You have gone through a number of literature about this meta heuristic. So I have a question: what meta heuristic is doing good with this CNN?
So,
What
sir, now there are couple of them that I can tell you is like ABC.
I'm just asking for just asking your findings. Which meta heuristic you find good?
Yes, sir. And the one that I recently utilized is well optimization technique, along with like oppositional based and applying chaos. So by applying a bit of chaos and chaos in terms of sign chaos, as well as by applying the oppositional based learning in well optimization technique, we found that it is working better.
Okay. Good. Thank you.
Thank you, sir.
Okay, sir. Thank you so much.
Swati ma'am.
Sir.
Paper ID 8, Acharya has joined.
Yes, sir. Yes, sir. I have just seen it. Yes.
Yeah.
Acharya, sir, are you ready to present? Paper ID 8, Acharya. Samirana Acharya.
Yeah.
Yes, sir. We can hear you. Please.
Yes. My voice is audible, ma'am?
Yes, sir. Can you please share your screen, sir?
Yeah. I'm sharing, madam. Yeah. I'm sharing.
Okay.
Yeah. Is it visible, ma'am?
Yes, sir. It is visible. Please turn on the slideshow, sir.
And Acharya sir, we have running short of time. Please finish your presentation within 10 to 12 minutes.
Yeah, okay. Very good morning, one and all. Myself, B. Samirana Acharya. And I'm doing my PhD in KL, Hyderabad, KL University. Hello, hello.
Rajesh Kumar Chatterjee, sir, can you please mute yourself?
Hello. Yeah.
Acharya sir, we can hear you. Please present your screen.
Some other voice is. Yeah, already I'm presenting, ma'am.
We muted everybody, sir. Please continue.
Okay, ma'am. So my voice is audible, ma'am?
Yes, yes, sir. Please go on.
Yeah, very good morning, one and all. Myself, B. Sameerana Acharya. I'm doing my PhD in KL University, and my guide name is Dr. K. Ramasubramaniam Garu. I'm doing my PhD in artificial intelligence. So today I would like to give my presentation on a comparative analysis of advanced machine learning based techniques to identify the cancer. So let us discuss. First of all, what is meant by lung cancer? Lung cancer is also known as lung carcinoma. So it is a malignant lung cancer.
Acharya sir, I'm sorry to disturb you, but you are not sharing your screen, sir. We are not able to see your presentation.
It is not visible, ma'am.
No,
already
sir.
Already I'm presenting.
Please close it again and then share it, sir.
Okay. Is it visible, ma'am, now?
Wait, sir. Yeah. No, sir, it is not visible again. Otherwise, you just continue with the normal PPT mode, sir.
Okay.
Don't turn on the slideshow. Normal PPT you just open.
Okay, okay. What about now, ma'am?
This is okay, sir.
Is it okay?
Yes, it is okay. Please continue in this.
Is it okay, ma'am?
Yes, yes, sir. Please continue. Sir, please continue. Can you hear me?
There are two main. Yeah. There are two main types of lung cancer. One is a SCLC and another one is a NSCLC.
I guess there are some connection issues with Acharya, sir. We'll move on with the next participant. Rajesh Banala, paper ID 20. Rajesh sir is there here?
Ma'am, Nagesh sir, this Nagaraj sir will represent, I guess.
Yes, hello, sir. Actually, sir is having a lot of internet net issues, I guess so. Technical issues.
Okay, paper ID 8?
Yes, sir.
Okay, right.
Yeah, my voice is now audible, ma'am?
Now it is okay, sir.
Okay. Thank you, madam. So basically, there are two major types there. One is the SCLC. SCLC stands for small cell lung carcinoma, and NSCLC, it stands for non-small cell lung carcinoma. So here, the most common symptoms are coughing. Coughing means including coughing of blood. So due to these many problems, so they will. There are so many problems are there: weight losing and shortness of breath and chest pains. And next, the vast majority. Okay, here the vast majority, 85% of cases of lung cancer are due to long-term tobacco smoking. About 10 to 15% of cases occur in people who have never smoked. These cases are often caused by a combination of genetic factors. So, exposure to radon gas, asbestos, and second-hand smoking or other forms of air pollution. So here, actually, machine learning and deep learning have recently played an important role to improve practical solutions to medical care. They also improve prediction precision in early and quick disease diagnosis, audio testing. So here, the physicians gain from such technological assistance since they are short on competent personnel and allowing them to see more patients, and furthermore, it enhances machine learning algorithms and the architecture of Apache Spark designed to detect the images and one of disease stages of lung cancer and more efficiently. So here, what I'm showing in this pictorial representation, which is purely discussing about the various kinds of disease per person. So there are different percentages are there. So these all are explaining about the how much percentage they are affecting. So here, actually, in my paper, there is existing techniques, the following disadvantages. So what is the existing? Yeah, ma'am, my voice is audible, ma'am.
Yeah, audible. You can go ahead, Jaldi.
Hello.
Yeah.
Yes, sir. Please carry on, sir. Yes.
Hello.
Sir, your voice is audible. Please go on. Sir, can you hear us? Acharya, sir, can you hear us?
Okay. It is not advised for... So here it is not advised for those who have underlying heart issues or have recently had cardiovascular surgeries. The possible symptoms include shortness of breath and dizziness and nausea. And the next is the radiation is administered to the patient through CT scans and X-rays, both of which endanger the patient's life.
Acharya, sir, can you hear me?
There are...
Acharya, sir, can you hear us? Madam, I guess some problem is there from his
Yes,
end.
sir, I guess so.
Okay, madam, we can call the next participant, madam.
Okay, sir. Again, sir has... Acharya, sir, can you hear us?
Yeah, madam.
Sir, you have 1 minute. You can just bind up your PPT. Just go to conclusion.
Yeah. I'm here. There are little bit network issues are there, ma'am.
Sir, just drop it. Session chairs, I just request you to please go with the queries. Acharya, sir, we are running out of time, so I just request you to please wind it up. Otherwise, we'll go with the queries.
So,
yes, Acharya, sir, you can bind up. You can bind up. You can bind up. A lot of network issue from your side, sir. Madam, you just call the next participant. I'll just sort it out. Huh?
Okay, sir. Done, sir.
Right.
Paper ID 20, Rajesh Banala. Vicky Nair.
Madam, Nagaraj, I think Nagaraj also
Nagaraj sir will present.
Yeah.
Nagaraj sir, can you hear me? Nagaraj sir, can you hear me? Sir, is my voice audible?
Yes, madam, your voice audible.
Okay. Somebody sharing screen. Rajesh sir, can you hear me? So please unmute yourself, sir.
Yeah, Nagaraj sir, can you hear us?
Sir, I think it is Rajesh sir's screen, sir. Rajesh sir, please unmute yourself.
सर क्या कर रहे हो सर? हम लोग वहां चीखे पड़े नागराज सर, बोलो सर.
Okay, we'll go with the next presentation. Paper ID 29. Akhilendra Nath, sir.
Yeah, we can move. Hello.
Let me share my screen, ma'am.
Akhilendra Nath, sir. Sir, Ashwini, sir, shall we
Yes,
continue
ma'am,
with the next participant?
Yeah, we can call Akhilendra. Yeah.
Okay, Akhilendra, sir, please. Share your screen, sir.
Okay, ma'am, I'm sharing. Ma'am, please give me permission to share, ma'am.
One second.
Akhilendra, can you hear us?
Yes, sir, I'm sharing.
Yeah, please share your screen. Yeah. Make
Is
it
my screen visible, sir?
Yeah, it is visible.
Thank you, sir. Good morning, one and all. My name is Akhilendra Nath, and our guide is Siddharth S. I'm going to present our review paper on an appraisal of cyber attacks and countermeasures using machine learning algorithm. This paper examines and compares some of the machine learning algorithms that can be used in IDS to detect a cyber attack. Since we all know, due to the growth of immense technology, the rate of cyber attacks increased exponentially. As a result, one must be in a position to identify these attacks, which can be carried out with the help of IDS. By using machine learning algorithms in IDS, we can make the IDS more robust and strong. So as we know that the rate of cyber attacks increasing exponentially and also mutating, means they are shifting, evolving into different forms, making them even more difficult to detect. So there is a requirement for strong machine learning algorithms in this case. So intrusion detection system basically classified into two types: misuse-based detection and anomaly-based detection. Coming to the misuse-based detection mechanism is that inspects for a specific type of pattern in viruses. For example, if there is a virus which is already attacked, then a hex value of that virus is stored so that next time when that virus attacks, it detects and gives an alert. But the drawback of misuse-based detection is it cannot identify a zero-day attack, which is having a new hex value. In order to overcome this drawback, anomaly-based detection came into existence. So what is anomaly-based detection? Anomaly-based detection does not check for pattern. Instead, it checks for a behavior of the network. So if there is a slight change in the behavior, it gives an alert. Since it also gives an alert for slight change, the false positives are heavy. So these are some of the most common attacks which take place. This graph depicts some of the recent attacks over years. Coming to the SQL injection is nothing but some of malicious SQL commands. These commands are used to compromise sensitive information from the database. These are quite common attacks. Coming to the denial of service, or commonly known as DOS attack, the attacker floods a server or a victim with a huge amount of packets, which causes the server to crash. Coming to the man in the middle, it is a kind of impersonation attack in which the attacker acts as a sender for the receiver and as a receiver for the sender, and intercepts the data. Coming to the brute force is a cryptographic assault in which attacker tries different combinations of the password to crack. Malware is a piece of malicious software which compromises the entire system. Botnets are a group of bots which are managed by a master or an attacker. These bots can be used to launch different types of attacks. For example, DDoS, distributed DOS. Some of the machine learning algorithms are decision tree. Decision tree is a supervised machine learning algorithm. It classifies nodes recursively, splitting the datasets into subsets. This is done based on the entropy and information gain of given attributes. Clustering. Clustering is an unsupervised machine learning algorithm. This algorithm groups data that are highly similar into the same clusters. If a new data enters, it checks for its characteristics and inserts into suitable cluster. Support vector machine is an unsupervised machine learning algorithm. This model is used to find maximum margin separation hyperplane in the feature space between two classes. The hyperplane is placed such that it is equidistant from nearest points of both the classes. So these are some of the attacks and these are the countermeasures. So SQL injection attacks can be detected using naive Bayes and gradient boosting. This model can be trained using the payload dataset obtained from libinjection. Libinjection contains all the malicious payloads to use, and cryptojacking can be detected using CAPSNet. CAPSNet is a prototype of biological neural organization which uses all the system features like RAM, processors, memory by implementing a host-based solution. It checks for the usage of those system features. Denial of service can be detected using a multiple linear regression model. After plotting the graph, the graph is examined with fit charts and residual plots. Identity spoofing. It is also a DNS attack can be detected using an SVM machine. In this model, a dataset containing history of all DNS cache servers is used to train. MITM attack.
Yeah, sorry to disturb you. Yeah, we have 2 minutes to bind up.
Okay, sir. This is a last but one slide. That's it, sir.
Right.
MITM attack. MITM attack can be detected using the random forest. Random forest is nothing but is a combination of 2 or more decision trees. It is trained with intentionally poisoned semi-duplicate packets. DNS tunneling. DNS tunneling can be detected using a decision tree, which is trained with numerous facets like the time gap between two successive packets, number of queries, and number of responses for a particular query. Malware threats can be detected using Ngram algorithm. Ngram algorithm is nothing but an algorithm which predicts the next step based on previous steps, like in a sequence. The machine learning models like SVM, linear regression can be used in this and used in this detection. So these are some of the analysis. Like we can use naive Bayes in detection of SQL injection, which gives an accuracy of 97.6%. We can use decision tree for malware detection, which gives an accuracy of 99%, which is high. We can use CNN in detecting DNS tunneling attacks, which is 99.3% accuracy. C4.5 with a combination of C4.5 decision tree and rep tree, botnets can be detected using 99.98% accuracy, and decision tree is used to detect DOS attacks, which gives a 97.28% accuracy. So we cannot completely eliminate a cyber attacks, but we can minimize their impact. The main objective of our study is to comprehend and interpret the most appropriate countermeasure for every given attack. By considering some of the machine learning models and their accuracies, one can choose the best model to safeguard against their attack. In future, we will enhance our work by presenting an ideas based on CNN that can detect some of that. One of the attack like DDoS, that is distribution denial of service, with a dataset KDD COP99. Thank you. Thank you for listening.
Thank you, sir. Session chairs, I request you to please go with the queries.
Madam, we have a keynote speak from 11:45.
Yes, sir.
We can call the next participant.
Achha, okay.
Paper ID 20, I guess.
Yes, sir.
Yeah.
Nagaraja sir is here. Paper ID 20, Nagaraja sir.
Yeah, he's sharing the screen, madam.
Yeah,
Nagaraj, sir,
good
your
morning,
voice is
madam. Can you hear my
okay,
voice?
sir. Yes, sir. Yes, sir. Please carry on.
Yeah, thank you, madam. Thank you. Sorry for inconvenient. Yeah.
Sir, you are not sharing.
So, good morning, one and all.
Yes,
So,
sir.
it's a very honor to on the part of this ICAIDS. Yeah. So,
Sir, can you please increase your
I'm
volume?
very
Your
thankful
volume
to
is
on the
very
part of
low.
this ICAIDS 2022. Okay. Volume.
Little volume high, sir.
Okay, sir. Okay.
Yeah, now audible. Now good, sir.
Volume.
Please go ahead.
Shall I continue, sir?
Yeah, continue. Now, yeah.
Yeah, right. Thank you, sir. Thank you, sir. So today my research topic is, sir, the performance of secure data deduplication framework in cloud services. So the introduction of my title, sir, the efficient storage of data on cloud has become very efficient with the use of the deduplication systems. The data deduplication is a technique that helps in tracking as well as removing duplicate copies of the data in storage space. By implementing the data duplication techniques, storage utilizations can be improved significantly, thereby reducing the cost of the storage. So the key issue that has to be addressed by cloud computing is data privacy and security. So the exactly by the problem statement of my project is the data deduplication makes it convenient to utilize the available disk space efficiently and proves as a solution for preventing data redundancy. Deduplication process allows only a unique set of data to be stored in the storage, and all other copies are the pointed towards connecting the points that points towards the unique data. So in this work, we propose a novel deduplication techniques that focus on preserving the client privacy. So we are preventing the based on the client privacy. So the suggested method uses an efficient deduplication algorithm which splits the input file into smaller units. So the each unit will get encrypted by the client using a secure hash function along with the chunk algorithm. So in this technique, the user construct one index tree with hash values of the small units and encrypts them using the asymmetric search encryption technique. So these are one of the techniques. So we are using the asymmetric search encryption techniques. So in this indexing tree, assist the CSP in searching index structure and also restores the requested units. So according to the my work, according to my suggest method, it enables the CSP to run deduplication without requiring the client plain text or decryption keys. So in my literature review, I reviewed many papers. So in that, I select the only three or four the main. So in this, we
Nagaraj,
I
sir.
use the conduct of the sir, sir.
Sir, please focus your work and then bind up because we have our keynote speaker from 11:45. So just 2-3 minutes. You just focus what you have done. Yeah.
Okay, sir.
Right.
So, right. Thank you, sir. In this, the literature review, just I use the data duplication process in this the cloud storage. So in this also, we are use the binary information of the data duplication attacks. So in this, we use the cross-user deduplication process. So move on to the next one. So these are the my literature review only. So go to the exactly my work, sir. In the my experimental design. So these are the my system architecture. In the system architecture, the architecture and the deduplication framework for clouds. So in the clouds, we are taking the data from the cloud, the proposed asymmetric extreme chunks to the data division into the smaller chunks, and we proposed and the rapid asymmetric maximums. So in this, we solve the data duplications by using the CSP. So in these clients are the processors, verifiers, the finders are these are data finders. These are the my client perceptions. So in this, I use the CSP algorithm that can be called as a chunk module of AE and the RAM chunking algorithm in CSP. So by using this one, sir, we get the my result analysis is here, sir. So based on my data set, the size is here, my size of my data set. So in this algorithm, so finally I got the the A and RAM chunk algorithm. These are my data sets. These are my size. Based on this size only, I get the efficient output results. So these are my output results. So here this is a RAM chunk. The red color is the RAM chunk. Here the blue color is the AE chunks. These are my output results. So more to the last one, is my conclusion of this my project is, sir, the data duplication process is divided into the 5 parts. So the first part divides the input files into smaller fragments. So it blocks the encryption algorithm, and hash algorithms are used to perform the encryption of the fragment in the second part. The generation of the index of encryption units takes place in the third part. So in this, we are the asymmetric searchable encryption process. The purpose of this asymmetrical search process, it uses for the encrypting the data index into the fourth part. So here based on this one, so the cloud storage provides to use the encrypted index for the searching the information in the fifth part. So these are the 5 parts. So finally, so based on this performance of applied chunk modules, chunk encryption module has high AE chunk endpoints and RAM chunk endpoints, whereas the index generation module has low AE chunk endpoint and high RAM chunk points. So these are my final conclusion. So here I based on here I divided into the 5 parts, sir. So in these 5 parts, first one is the fragments, second one is block encryptions. So next one I use the generation of the index of encryption unit, that is the third part. The fourth part I use the asymmetrical searchable encryption process. So finally I use the cloud storage provider use the encrypted index for the searching the information of information. These are the 5 parts. Thank you, sir. Thank you very much. So this is the.
Okay, sir. Thank you, sir. Thank you, Nagaraj sir.
Thank you, sir.
Thank you.
Actually, we don't have time to ask a question. So, madam, please bind to the presentation.
Okay, sir.
Because we have our keynote speed, keynote speed from 11:45 onwards.
Yes, sir.
Okay, sir. Thank you, sir. Thank you very much.
Thank you.
I thank all the session chairs, Dr. Saumi Datta ma'am, Dr. S. Venkatrajitra sir, and Professor Jitendra Kumar Seth for taking their time out for the session and gracing the session. Thank you very much, sir.
All the session chair, I am very thankful on behalf of Sreyas College and on behalf of ICAIDS-2022. Thank you for sparing time to chair the session. Saumi Datta madam, Gautam sir, and Venkatrajitra sir.
Thank you. Thank you, sir.
Thank you, sir.
Jitendra sir, madam, Bhiksham sir, Ashwini sir, Swadhi ma'am. Thank you.
Thank you very much, sir.
Thank you.
Well done, participants. Have a nice day.
Thank you, sir.
Madam, we can call our first keynote.
Yes, sir.
Yeah.
Yes. I'm very much delighted to introduce our first keynote speaker, Professor Mohammad Usman sir, for the speech on artificial intelligence in healthcare using speech as a biomedical signal. I'm equally delighted to read sir's profile here. Professor Mohammad Usman sir is from King Khalid University, Saudi Arabia. Dr. Mohammad Usman sir is currently associated with Department of Electrical Engineering, King Khalid University, Saudi Arabia, and he is the senior member of IEEE. He also serves as a consultant to technology firm HiMet Limited, United Kingdom. He received his PhD degree in electronic and electrical engineering from University of Strathclyde, Glasgow, United Kingdom in 2003 and 2008 respectively. His research interests include mathematical modeling, signal processing, and AI techniques with a focus on wireless communication and biomedical signal processing applications. He received the Academic Excellence Award at King Khalid University in 2016 and Research Excellence Award in 2020. He is also the organizing chair and TPC chair of IEEE International Conferences and also served as the editorial board for prominent international journals. We are very much delighted to have you here, sir. I request sir to take over the session.
Yes, Usman sir, can you hear us?
Yes, thank you all very much for having me on this conference as a keynote. It's my pleasure to give my presentation here. And let me begin by starting to share my screen.
Yes, sir, we can hear you, sir. Please share your screen.
All right, okay. Is my screen visible, right?
Yes, sir.
Yeah,
Yes.
right.
Okay, that's fine. And, Okay, let me put the slideshow on. All right, the topic of my presentation today is to talk about using speech as a biomedical signal for the purposes of medical diagnosis and healthcare. And in that context, I'll be talking about how artificial intelligence can be used as a tool to achieve that purpose. So much of the presentation will be dealing with the justification of using speech as a biomedical signal and how it can contribute to improving the healthcare system and improving early diagnosis and treatment of patients. So the structure of my talk is organized as follows. First, I'll be covering about the role of engineering in medicine. So normally we think of engineering as and medicine as completely different fields, but there is a significant role of engineering in medical applications. So I'll be briefly touching about that. And then in the second part of the speech, I will be talking about the biomedical entropy of speech, which is nothing but finding out what is the biomedical information that is embedded or inherent in human speech and how that can be exploited to make medical diagnosis and to help in treatment. And the third section of my talk is related to artificial intelligence and how artificial intelligence is being applied in medicine. And again, AI has applications nowadays in almost all aspects of our life. So our focus here is how AI is being used in medicine, and specifically how my team and I have been working on applying AI to address medical issues using speech as the biomedical signal. And towards the last part of my talk, I'll be discussing some of the ongoing research that my team and I have been working on over the last 3 to 4 years. And towards the end, the aim is to motivate people to to start working in this field, because it's a very promising field of research, which can also have meaningful implications for society at large. So that's the whole objective. So let's begin by talking about the role of engineering in medicine. So when you talk about engineering in medicine and how engineering is being applied in medicine, we can talk about how there are electronic components in medical devices. There's a lot of signal processing being done or to all the signals that are being captured by various sensors. And of course, we need to have sensors to capture those biomedical signals themselves. Again, that involves engineering aspects. And then there is material science. And there's many more different aspects of engineering that lead to a branch of engineering called as biomedical engineering. And as we see here, it's the field of biomedical engineering is a highly interdisciplinary study of various other established fields. But over the years, biomedical engineering has itself established as a specialization in its own right. So it requires the interdisciplinary study of various aspects of engineering and contributing towards medical applications. And the role of engineering in medicine can be categorized into three broad categories. The first part is the diagnosis aspect, where we will be using engineering techniques to aid medical professionals in the diagnosis of ailments. And the second aspect will be the actual treatment of the illness itself, how engineering techniques and devices are being used by medical professionals to treat the ailment. But in between, there is the aspect of monitoring the patients. Usually, the monitoring of patients takes place after the diagnosis has been done, when the patient has already become ill and the treatment is ongoing. But what we are trying to do is, if we can find a convenient way in which we can monitor a patient's health continuously and regularly, then that will enable us to perform the diagnosis much earlier, even before the illness becomes more serious. And that way, the treatment can begin much earlier, and it can avoid serious casualties or serious illnesses at a later stage. So in that context also, I'll be arguing later on that speech can be beneficial in monitoring on a continuous basis, because conventional monitoring techniques, which require specialized medical devices and connection of the patient or attachment of the patient to those medical devices, is rather inconvenient. So, by using speech as a biomedical signal, we could possibly monitor patients on a continuous basis and thereby be able to diagnose any ailments at an earlier stage and begin treatment also much earlier. So as I mentioned earlier, the field of biomedical engineering involves a wide array of engineering disciplines coming together and contributing towards a common goal of assisting medical professionals. So it's a highly interdisciplinary field, but it has also established itself as a specialization in its own right. I'll not go into all these, individual applications specifically, but the whole point of the slide is to give an idea that it is such an interdisciplinary field involving various aspects of engineering. Now, coming to medical devices, the aim of a medical device is to measure some characteristic or some parameter of the human body and present it to a medical professional in a way that they can meaningfully read it and interpret something and be able to diagnose and treat the patient. And we have medical devices ranging from very simple devices like a thermometer or a blood pressure monitor or a pulse oximeter, which are like commonplace devices almost available in all houses nowadays. But there are more complex devices like, for example, an MRI machine or a CT machine or an ultrasound machine, and so on. So we have medical devices ranging from very simple devices to more complex devices. The simple devices that we usually have at home do not actually require specialized training to operate them. We can just use it. Even non-medical professionals are able to use those simple devices. But the more complex devices require qualified and trained specialists to operate them and also to use them. So I know there's a risk associated with these more complex devices, and of course it has to be used only by specialized trained professionals. And of course there's the cost aspect of these devices as well. So not everyone can have these expensive machines at their homes. So there's a so we have these medical devices which are ranging from very simple devices and very less expensive to the more complex and more expensive devices, and so on. So the whole idea is now when we want to monitor patients and when we want to diagnose patients, we have to use some of these medical devices and try to get some understanding of what the patient's body is behaving like, and if there's any irregularity or abnormality, and how that can be cured if there is any. And what we are trying to say is, instead of using any of these devices, if we can find some other device which is more commonly available and be able to measure some other signal of the human body, which is more easily available and available almost all of the time, it would help medical professionals in making the diagnosis much simpler and much quicker. And then we have, in more recent times, medical devices coming as wearables. So we have on this left side of the screen, where we have a blood sugar monitor applied as a patch to the body, and that can continuously monitor the blood sugar level of the individual. And it is linked through via Bluetooth to a specialized device, which can keep giving readings of the blood sugar levels at regular intervals or even continuously. So again, what we notice here is that we need to attach this device to the human body. And then we have smart watches nowadays, which have a lot of health-related applications and sensors built into them, which allows us to monitor a lot of different parameters of the human body. But a common aspect of all these devices is that they have certain components within them, which can be broadly classified into these four categories. The first component is the sensors aspect, which the job of the sensors is to capture the signals that are being produced by the human body. And then there is some electronics and some signal processing involved to process those signals and to analyze those signals. And finally, of course, there is some software or algorithm or user interface that will present that signal to the end user in a meaningful format that can be read and interpreted. But what we notice about all these devices is that most of these devices have a limited and specific usage. For example, a thermometer can be used only to measure the temperature, the BP monitor only to measure the blood pressure of the individual, and so on. So each of these devices has a limited and specific usage. And some of the devices can also be expensive. And to have a separate device for each purpose is adding cost to the process. So why can't we have some common signal and a common device which can cover a wide array of applications and not be limited to a specific application? So that's the point we want to explore. So as I mentioned here, these are some examples of biomedical signals which are captured from the human body. Like the first one here is an ECG signal. And then we have at the bottom part, which are EEG signals. So again, to capture these signals, we use some form of a device which has sensors to capture the device. And then there is some electronics involved. And the purpose of the electronics is to amplify the signals, because usually the signals produced by the body are very weak, and that needs to be amplified to the required level before it can be processed for analysis and presentation to the end user. And the third part of the process of the components is the signal processing aspect, where the signal will be cleaned up. Again, the captured signal may have some distortions or noise associated with it. That needs to be cleaned up, and signal processing can help in doing that. And then we need to analyze that signal and present it to the end user via some software or a user interface. So the whole objective is the signal that is being presented to the medical professional should have some meaningful interpretation, which allows the medical professional to make some judgments about the person's health conditions. So conventionally, the process of analysis is done using signal processing. But as we move forward, AI is going to play an important role here in the analysis of the signals, and thereby assisting in the process of presenting the signal and making some decisions on behalf of the medical professional, or even assist the medical professional in making the correct decisions, and thereby minimizing erroneous diagnosis procedures. So that's the general aspect of the medical devices. Now, a common aspect of all these medical devices, which are used to capture the signals produced by the human body, is that, as we can see from these images, they need to be connected to the human body. So what we call this as being invasive. So we need to attach these sensors to the human body, or in some cases, even if you don't have to physically attach it, we have to put the device in close proximity to the human body, like, for example, an X-ray machine or an MRI machine. We don't actually attach it to the body itself, but we have to be in the vicinity, but that exposes the human body to radiation. So there are other disadvantages as well. So again, the argument here is that if we can have some form of a signal that can be captured from the human body without connecting anything to the body. And if that can be done on a continuous basis, that will help a lot in diagnosis. So as you can see, because of these connections, because of these attachments to the human body, it is not possible to have these connected all the time. And even if we do so, it's going to be rather inconvenient to the patient. So we are going to pose 3 questions here. to ask ourselves if we can overcome these difficulties of existing medical devices which require attachment to the human body. So the first question here is that, is there a signal generated by the human body that is easier to acquire? We'll explore that and we'll try to answer that question in the next couple of slides. And the second question we are going to ask is, okay, if there is such a signal that is easier to acquire, do we have a universally available sensor that can capture the signal? And we want to have a sensor or a medical device that can capture the signal in a low-cost way and also be able to capture that signal almost everywhere on a continuous basis. So that is the second question we are going to ask ourselves. And again, let's explore that in the next couple of slides. And the third question we'll ask is, okay, we have a signal that is easier to acquire. We have a sensor that can acquire that signal, but is that signal actually having any information that is relevant for diagnosis or not? Otherwise, it's just useless. So we are going to pose these three questions and try to explore the answers to these questions. And that will give us some prospects of being able to use that signal for the purpose of diagnosis and treatment. So that leads us to the second section of my talk, which is the biomedical entropy of speech. So by entropy, we mean the information in speech. So does speech have any biomedical information that can allow medical professionals to diagnose an individual's health condition by analyzing the individual's speech characteristics? So let's explore that. So we have posed these three questions. Is there a signal generated by the human body that is easier to acquire? And needless to say, it's an obvious thing that speech is a signal that is generated by us almost every day throughout the day. And of course, it's easier to acquire. So all we need to acquire that signal is a microphone. So that leads us to our second question, which is there a universally available sensor to acquire the signal? Of course, there is. This microphone is available almost with everyone, everywhere nowadays. So we have almost everyone has a mobile phone or a smartphone with them, which has a built-in microphone into it. So the speech signal can be continuously monitored and analyzed to diagnose a patient's health if it contains any biomedical information. So that's where it leads us to our third question. Does speech signal have any meaningful information that can be used for diagnostic purposes? So we'll try to answer that question. And to answer that question, if speech indeed has any meaningful information for medical diagnosis, we need to think about the speech characteristics of individuals. And it's common observation that the characteristics of speech get altered because of the emotional state of the individual. This is something we are all familiar with. For example, if you hear someone talking over the phone, even though that person may not be in front of you, just by listening to their speech, we can identify their emotional state, whether they are happy or sad or angry or tensed. Their speech characteristics reveal that information. So clearly, there is some changes happening in the speech production mechanism, which alters the speech characteristics, which is closely related to the emotional state of the individual. And that characteristic is changing and becoming observable depending on the present emotional state of the individual. So clearly, there is some information in speech related to the emotional state of the individual. And similarly, there is information related to the physiological state of the individual, which again we can closely associate if we try to recall how our ability to speak gets affected immediately after we have performed some intense physical activity. So once we have done some workout or played a game of football or something, when we try to speak immediately, when we are breathless at that moment, our speech characteristics get altered. So again, that means there is some connection between the speech characteristics and the physiological changes that have happened in our body as a result of the physical activity that we have performed. So by analyzing that speech, we might be able to understand what those physiological changes are, and based on that, be able to make some diagnostic decisions related to the body. And the other aspect of of the human body that can affect speech is related to breathing disorders. Of course, because the speech production mechanism of the human body involves the mouth and the nose, which is also used for breathing. Uh, any effect in the breathing system or the respiratory system of the human body is going to have a direct impact on our speech characteristics. So by analyzing the characteristics of speech, we could be able to diagnose a lot of health conditions associated with our respiratory system. And finally, we can also, gauge or assess the health condition of our heart conditions by analyzing the speech. Of course, the heart is not directly involved in the production of speech. It's the lungs and the respiratory system that is involved in the speech production mechanism. But there is an interaction between the heart and the lungs that is required for the oxygenation of blood, because when we breathe in and breathe out, there is an exchange of oxygen and carbon dioxide, and that exchange of carbon dioxide has to go through the blood, and the heart is responsible for pumping that blood, right? So there is some interaction going on between the heart and the lungs for the oxygenation of blood, and therefore any malfunction or disorders of the heart can have an impact on the lungs itself, and thereby reflect itself in the speech characteristics, which can then be used for diagnostic purposes to determine any ailments of the heart. So again, these are just some broad categories of aspects of the human body which can affect the speech characteristics of the speaker. So there is some evidence or justification that the speech characteristics of an individual are affected as a result of various changes in the human body, and therefore we can say that there is biomedical entropy, or in other words, the speech of an individual contains information that is a reflection of their health characteristics. So therefore, speech can be used for diagnostic purposes. So by analyzing the speech characteristics of the individual, we could make some diagnostic decisions, and also make some decisions related to the treatment of the individual for those ailments. So as we've been saying here, there is some information about the health condition of the individual embedded in speech, and that can be exploited to study or to diagnose various pathological conditions of the human body, but that is not without its challenges. We have three main challenges associated with using speech as a biomedical signal. The first is that there is not enough data available which maps the human speech with an associated health parameter. So there is not much information related to that. So it is still a work in progress. There are some initial findings available in the literature, but again, there is a limitation on the amount of data itself that can be used for making those decisions. The second challenge is identifying what parameters of the human body can be associated with what parameters of the speech characteristics. So we have various parameters of the human body, like, for example, our breathing rate, our heart rate, or the oxygen concentration in the blood, or the temperature of the human body, and so on. So which of these parameters have a correlation with which characteristic of speech? Because speech is a time varying waveform, and of course it has information in the time domain, and we can also extract some information in the frequency domain. So we need to identify which parameters in the time domain or in the frequency domain are associated with which parameters of the human body, and thereby, correlating those parameters with each other. And that is a challenge, with respect to using speech as a biomedical signal. There are, some results and existing literature which has, correlated certain parameters of the human body with certain aspects of the speech characteristics. Again, there is scope for a lot more investigation on this, and that is another challenge and open for research. And the third aspect of the process of using speech as a biomedical signal is the actual design of the algorithms and the choice of algorithms itself. So how are we going to make those decisions based on speech? So we need to come up with the algorithms which can perform those tasks and perform those tasks with high accuracy as well. It's not just perform, but perform with high accuracy. Thereby, we need to minimize wrong diagnosis and wrong treatment, and also avoid the failure of diagnosis itself. So there are various challenges associated with this. And again, that is what research is going on to address these challenges. Now, the use of speech for biomedical applications can be divided into three categories for the purposes of monitoring and diagnosis. The first category is for monitoring the physical health of the individual. So that is to measure certain biomedical parameters, like measure the heart rate of the individual, measure the BP, like what a doctor would do as soon as you enter the clinic. And the first thing they do is check your temperature, check the BP, and the basic important vital parameters of the human body, and thereby extend it for further investigation and perform diagnosis and so on. So similarly, when we are using speech, one of the categories of investigation would be for analyzing the physical health of the individual. And to measure to assess the physical health, we'll need to measure certain biomedical parameters of the human body. And using those parameters, we have to use some diagnostic algorithms to make some diagnostic decisions. And then we can proceed to medical intervention if there is a need for it. The second category of investigation would be for the diagnosis of mental health conditions, because clearly the speech characteristics are affected as a result of various changes in the emotional state of the individual. So the mental health of the individual can also be investigated and diagnosed by analyzing the patient's speech. And again, by being able to monitor the speech on a continuous basis, if we can, we might be able to diagnose these conditions at a much earlier stage. Speech gives us a specific advantage, because it can be monitored on a continuous basis, because the person keeps speaking several times in a day. For several hours during the day, we keep talking to individuals, and we have a mobile device with us all the time. So if we can have an app on the phone which is continuously analyzing our speech and processing it and making some decisions, it can at least give us an alert that there is some issue with you. Please contact a medical professional and get yourself checked. So, rather than ignoring our conditions, it can keep prompting us to seek medical intervention at a much earlier stage. So that's one huge advantage that speech gives us. And the third category of investigation is specifically targeted to professional athletes. Now, professional athletes are highly, they have very highly tuned bodies. And their body parameters are highly tuned, and they have to be within specific ranges because they have to perform at their peak at all times. So monitoring a professional athlete for any variations in their body parameters is essential. And typically what happens is for professional athletes, they are monitored by connecting probes to their bodies and measuring their body parameters. But again, as we'll see in subsequent slides, having such connections to the human body or attachment of various devices to the human body can be very inconvenient. even for the athlete. So that is another category of investigation that we can work on, whereby the use of speech as a biomedical signal can be a very useful application. So this was what I was mentioning about. So, for example, monitoring of professional athletes for their performance levels when they are on when they're on the field. This requires connection of various probes or devices to their body, and that is rather inconvenient. And even for normal individuals, when having such devices and probes and sensors connected to the body, makes it very inconvenient. So we call this as invasive. So this is invasive to the human body because the human body has to be attached to all these devices. So it becomes invasive, which makes it inconvenient. So if we can have speech as a biomedical signal, then we do not need to attach anything to our body. So that gives us the possibility of non-invasive diagnosis by using speech as a biomedical device. The second advantage it gives us is that it does not require any specialized medical device, because all it requires to capture speech is a microphone, which is available with just about everyone on their mobile device. So it makes it rather simple to acquire and capture this signal. And because it is available and it does not require a specialized device, it is low cost and ubiquitous. It doesn't, of course, there are smartphones which are expensive, but the microphone itself is not very expensive. So we can say that the device required to capture speech is comparatively low cost, and it's ubiquitous in the sense that it is available almost everywhere with just about everyone. And that also extends the functionality of the smartphone itself. So we have the smartphone, which is already having multiple purposes of usage for us in our daily lives. So with being able to use speech as a biomedical signal, our mobile device can also act as a medical device to monitor our health conditions and prompt us to seek medical intervention at an early stage. So it will become much advantageous if we can achieve and have such an application on our medical device. Of course, there are many other applications which do monitor health conditions, but not many of them use speech as the signal. They have other sensors to capture the biomedical signals, and using those signals, it analyzes and tries to diagnose and determine your health condition. But we have to remember the fact that by using speech as a biomedical signal, we are not trying to replace existing medical devices. Okay, this will only complement existing medical devices for diagnostic purposes. The objective is not to replace it. Of course, the use of speech has some advantages, but it is by no means the objective to. It is by no means the objective to replace existing.
Please unmute yourself, all the participants. Please unmute yourself.
Rahul sir, number 1.
Sorry for disturb, sir. Sir, you can start now. Sir.
Yes, sir. Please carry on, sir.
Usman sir, please unmute yourself. Usman sir, please unmute yourself.
Is it okay now?
Yeah. Okay, sir. Okay, thank you. Sir.
Am I audible? Yeah. Okay.
Yeah.
So as I was saying, the use of speech as a biomedical signal will complement existing medical diagnostic techniques, and by no means it is meant to replace existing techniques. So it will complement and enhance healthcare and make the healthcare prospects better. But we need to remember that it is not going to replace existing techniques. Okay, it has its advantages, but it is by no means going to replace the other conventional techniques. And finally, another advantage of using speech as a biomedical signal is that it can be acquired from a remote location, in the sense that the patient need not be physically present at the doctor's clinic to acquire that signal. Because we have communication systems now, the speech of the individual can be acquired from anywhere in the world, and the medical professional can analyze that signal on his device and make some decisions related to the diagnosis and so on. So it facilitates remote monitoring of the individuals. And that again is an important aspect or is important advantage of using speech as a biomedical signal, because for example, if there is a patient undergoing some treatment but does not require hospitalization, the patient is sent home and they are taking medication and they are taking treatment at home. And the doctor can periodically monitor the progress of their treatment by analyzing the speech, which can be acquired without the patient having to visit the clinic or the hospital. So it enables remote monitoring of the individual because we have our existing communication systems which can move the speech signal from one place to another. So that's another advantage of using speech as a biomedical signal. Now, coming on to the physiological effect of speech, I'm just going to give you one example of how physiological effect is affecting the speech characteristics of the individual. And normally, physiological changes in our body happen for a variety of reasons, such as aging or the exposure to pollution, our stress levels, and also our physical activity. The first three here cannot be induced. Right? These are natural processes or exposed to physical environment. But one of the things which can be artificially induced is by physical activity. And the objective here is to show that or give some evidence that the characteristics of speech indeed get affected and altered as a result of certain physiological changes in the human body. So what we will do here is, we ask certain individuals to perform physical activity, that is some intense exercise for a certain duration of time, which will alter their physiological condition. And once the physiological condition has been altered, we will ask them to read some paragraph or sentence and record that speech of theirs and check whether that speech has any changes in its characteristics or not. So the physiological response to physical activity or exercise depends on various factors like the intensity of the exercise, so how intense the activity is, the duration of the activity, for how long it's being done, and how regularly that activity is being performed by that individual, and also the environment in which the activity is being performed. So by inducing some physiological change in the human body, by asking individuals to perform some physical activity, we notice that there is some physiological there is some change in the characteristics of the speech as a result of the physiological changes that have been induced in the body. So how do we know that? We know that based on quantitative studies, where we have taken a very state-of-the-art speaker recognition system, which identifies who the speaker is. And normally, the speaker recognition system has a very high accuracy. But when we take the speech signal of an individual who has been registered on the speaker recognition system, but after the speaker has performed physical activity, the accuracy of the speaker recognition system is reduced quite significantly. So this indicates that the characteristics of the speech have got altered as a result of the physiological changes that have been induced in the body by performing exercise. So this gives us a reasonable evidence that speech characteristics are affected because of changes in the physiological conditions of the human body. So to illustrate this, what we have here is the recording of a speech signal of an individual, where a sentence, "a quick brown fox jumped over the lazy dogs." That's the sentence being recorded, being read out by the individual. And this is the time domain waveform of that recording. And what we have at the bottom here is the spectrogram of the signal, which gives us the the spectral representation of the signal in various time slots. So that's the recording of the individual before they have performed any physical activity, that is, before any physiological changes have occurred in their body, that is under their normal state of physiological condition. And then we have the same person to record the same sentence, but after performing intense physical activity for 10 to 15 minutes. And what we notice is the same sentence, when we listen to it, it sounds similar, but the speech characteristics, when you look at the waveform, the time domain waveform, as well as the frequency domain representation in the spectrogram, we see that there are some changes involved. So that means there are some temporal as well as spectral changes that have happened. Or in other words, there are some changes in the time domain characteristics of the signal of the speech, as well as some frequency domain characteristics of the speech as a result of the physical activity. So that on the left side is the speech and its spectrogram before the activity, and on the right side is the speech and spectrogram after the activity. And clearly, we can see a noticeable difference in the characteristics of the speech, both in the time domain as well as in the frequency domain. So the argument here is that physiological changes in the human body have an effect on the characteristics of the speech signal. So therefore, by analyzing an individual's speech signal, we could possibly detect the medical conditions or the underlying health conditions of the individual. So clearly what we notice in particular here is that the unvoiced components of speech are relatively suppressed. What we mean by the unvoiced components of fricatives is that the sounds like S and H, right, which are not produced from the throat, these are being affected. These are becoming suppressed. And the reason for that is because the production of speech mechanism requires us to breathe. There is movement of air through our vocal cavity. So there is some breathing involved in producing the various sounds in the human body. And when we perform physical activity, it increases our breathing rate. And therefore, it's like a competition between the requirement of breathing for our metabolic reasons and the process of breathing for the speech production reasons. And there is a competing need for this. And naturally, the metabolic reason or the metabolic requirement supersedes the speech requirement. So the body has to survive first. So it fights to survive first. And therefore, the metabolic requirement of breathing supersedes the breathing requirement for producing sounds. So that because of that, the sounds that we produce get altered, or in other words, the characteristics of speech get altered. So clearly, there is some relationship existing between the physiological parameters of the human body and the speech characteristics. So clearly, we can, from common observation, we can see that when a person has done some physical activity, they become breathless and their speaking ability is affected, and the pattern and the speech rate also gets affected. So there is a reasonable change that we commonly observe in the speech characteristics of the individuals as a result of the changes in the human body. So we want to exploit this to be able to make diagnosis of various underlying health conditions by using speech as the signal from the human body. So we will use this correlation between speech and various parameters of the human body to make the diagnosis. And based on literature so far, there is evidence of being able to measure heart rate from speech. There's also evidence of being able to measure heart rate from the spectral features of speech. There has been applications of measuring the blood pressure of individuals from speech signals, the variation of blood pressure, the reactivity of the heart has been also been measured. Again, the features of speech that are being used here is the rate of speech, how quickly or how slowly the person is speaking, and the variations in the loudness of speach. These are like features which can be used for measuring certain parameters, like in this case, heart reactivity. And then we can also identify the emotional state of the individual. Again, a feature that is commonly used from speech to measure the emotional state is the speech rate. Again, it is normal, finding that when somebody is angry or stressed, they tend to speak much faster than they are in a normal state of mind. And sometimes we can also measure certain parameters of the human body, like the oxygen concentration in the blood, in an indirect way, not directly. There is no direct correlation between speech and the oxygen concentration, but it has an indirect relationship through the heart rate. So the oxygen concentration of the blood has a correlation with the heart rate, which in turn has a correlation with the speech of the individual. So by correlating these things, there is evidence in the literature of being able to measure the oxygen concentration in the blood by analyzing a person's speech. So there is reasonable evidence in the literature that points to the fact that the health condition of an individual can be monitored from speech. And what motivates us further in this regard is that the mobile device and smartphone is so ubiquitous and available everywhere with just about everyone. And because it has the microphone as a common sensor, it can be used to capture the speech signal of human beings and monitor their health conditions, providing a wide range of applications for timely diagnosis, rehabilitation procedures, and so on. So there are various ways in which we can use speech as a biomedical signal to improve healthcare in general. Now, the research opportunities in this regard, it can be directed into several categories. The first is to associate parameters of the human body, like heart rate or blood pressure or oxygen concentration, with various characteristics of the speech signals, as we discussed before. Again, not all the existing systems are highly accurate, so we need to improve these algorithms to make them more accurate. We need to, there's also an opportunity to develop new diagnostic tools and algorithms using speech, and also to improve the accuracy of existing techniques. Conventionally, it has been, what is being used is signal processing to do all these processes. But going forward, we have a paradigm shift by using machine learning and deep learning and AI-based techniques to analyze speech signals and be able to make diagnostic procedures. And of course, it is not without its challenges. To use machine learning and deep learning, we need large data sets to train and develop the models. And the models and the algorithms can be computationally intensive. But again, we have the processing power nowadays that can cater to these requirements. The large data sets aspect, it's a challenge, but it is not impossible. It is indeed possible to collect data over time and improve the systems with high accuracy as we go along. So that leads us to the third aspect of this talk, which is the role of AI in medicine. And let's talk about briefly what AI is and how machine learning and deep learning are subsets of artificial intelligence. So as we must be quite familiar, AI is trying to mimic human behavior, and a subset of AI is machine learning, where the behavior is adapted and improved with experience. So thereby it does not repeat mistakes of the past and improves by learning from its previous mistakes and so on. But the characteristic of machine learning is that it relies on features that we have to identify and give as input to the machine learning algorithms. So the features have to be determined by us. But a further subset, a further evolution of machine learning is deep learning, whereby the features are identified by the deep learning algorithm itself. So we don't need to specifically extract and identify those features. Rather, the algorithm itself will identify the most important features from the signal and use it to correlate with the certain aspect of the end result that we are interested in. So that's how we can use ML and DL in our applications. Now, what are the enabling factors that make machine learning so attractive? We have powerful processing capability nowadays, which allows the efficient and quick computation of complex algorithms. And then, we need the low-cost data storage to store the large amounts of data. And again, that is something that is feasible and available nowadays. And the data need not be located at a single place. So the data that we need may be available at various geographical locations. So we need to be able to access and process this data at various locations. So the advent of distributed and cloud computing contributes as an enabling factor to this. And then we have the ease of visualization. There are tools which enable us to visualize this data in a simple and meaningful way and make decisions very quickly by being able to visualize that data in a very efficient way. And to do the algorithms, we have a lot of open source machine learning tools and available algorithms which can be applied for various purposes. So that's another enabling factor. And finally, we have the data itself, okay? And we call it as the data with the 4 V's. The volume of the data, we have a high amount of data, a large amount of data available. The velocity, by velocity, we mean the data can be moved around very quickly from one location to another. There is a huge variety of data, and there is veracity in the sense the data has to be accurate as well. So there is veracity of data. So by having data with these 4 V's, and by processing this data using machine learning algorithms, we can add a 5th V to this, which is called as the value. So this data, which was just huge and sitting there, we can analyze the data and make it more useful for various applications. In our case, by having a large amount of speech recordings of various individuals, we can analyze this for diagnostic purposes and have various biomedical applications. So the data becomes now valuable. And of course, there are other aspects of AI in medicine, whereby we have a typical scenario here, where an individual, a patient, may be visiting multiple hospitals, multiple clinics, and at various places, he's being treated for various ailments, and various signals or parameters of their body are being captured. These can all be stored in some central location and can be accessed and analyzed from anywhere by anyone who has access to it. So AI can assist in analyzing these data sets, which are available in huge quantities at various locations, and thereby it can assist medical professionals as well as family members in taking care of the patients. So this is a broad application of AI in medicine, but our focus here is more on the application of medicine to analyze of AI to speech. Usually speech is not recorded. If you go to a clinic, nobody records your speech or nobody collects the speech for diagnostic purposes. But by being able to use speech as a biomedical signal, we might be able to make those diagnostic decisions using speech. Now, at this point of time, there are AI algorithms which are in fact competing or even outperforming doctors. So there is some algorithm developed by Google which has outperformed doctors in identifying a certain kind of cancer by classifying images. So the doctors may have missed the diagnosis in certain cases, but the algorithm was able to detect it. So AI algorithms have become highly advanced nowadays, and they are already outperforming or even competing with doctors. But it is not just about outperforming or competing with doctors, but more important thing is AI can assist doctors. It can reduce the doctor's review time and improve the diagnosis accuracy. I know one of my collaborators, who works as a medical professional in the United Kingdom. Even before the medical reports come to the doctor's desk on his system, The AI algorithm has already analyzed that report and gives the doctors cues as to where to look at in the medical image or so on. And so the doctor has already got some information from the AI that he can focus on. So that reduces the doctor's review time and also improves the accuracy of the diagnosis. Of course, the deployment of AI requires regulatory approvals. And another challenge in using AI in medicine is that there is a gap between the AI engineer and the medical professional. So the AI engineer does not have much knowledge about the medical aspects, and the medical professional does not have much knowledge about the AI and engineering aspects. So there needs to be some bridging of the gap between the AI engineer and the medical professional, so that the algorithms, after making the analysis, can be presented, the results can be presented to the medical professional in a meaningful way that can help in the diagnosis of the patient. So that is another challenge which requires close interaction between the engineering community and the medical community. Now, coming to data extraction, the feature extraction, when we talk about speech as our biomedical signal, we need to extract certain features from speech, which will become the input features to the machine learning algorithms. And if these input features are chosen inappropriately or incorrectly, then the diagnostic results that we're going to get are not going to be good. So, as the saying goes, if the data is bad, the tools are just going to be useless. So in a machine learning, if the input is not meaningful, the output is also going to be very, it will also not be meaningful at all. So we need to choose the right data in the sense that we need to choose the correct features from the speech signal that can be used for measuring certain biomedical parameters or for diagnosing various health conditions. So we need the right data, which is correctly and properly labeled, and the data also has to be accurate. So which is, these are aspects of the 4 V's that we talked about earlier. So once we have the right data or the right features from the data, we can develop the predictive model, which can be used for measuring various biomedical parameters of the human body. And coming to the last aspect of my talk, I'll be talking about some of the ongoing research that my team and I have been working on over the last, say, 3 to 4 years. And we're also currently working on various of these things still. So I'll just discuss a few of those findings and also point out some of the challenges that we have faced along the way. Now, the choice of features from speech, is itself is a challenge. How do we identify which features are good for which application, and from which domain do we extract those features? Whether we take those features from the time domain or from the frequency domain, as we call it, as a temporal or spectral domain. So there are various different features associated with speech. And we need to use one of these features as input to the machine learning algorithm, which can then analyze those features and give us some meaningful output. So there are various temporal features associated with speech. And then there are also various spectral features associated with speech. I'm not going to go into the details of each of these. But generally, if you recall from the plots that I showed, there are changes not just in the time domain or in the frequency domain, but in both. As if you recall from the plot that I showed earlier. So we focus on features which have both time domain and frequency domain characteristics. And in particular, we focused on these features, which is the short time Fourier transform, which is basically the spectrogram of the signal. And then we have these MFCCs, which is the Mel frequency cepstrum coefficients. And then we have a variation of that, which is the Mel frequency discrete wavelet cosine transform. So we have various temporospectral features, which are more useful rather than using features from a single domain. So we have used, in particular, STFT and MFCC in our studies, and used it for the estimation of heart rate of an individual. So basically, by analyzing a person's speech using MFCC features, we have used machine learning algorithms to detect what is the heart rate of the individual. So while recording the individual speech, we also measured the heart rate of the individual by using a conventional medical device. And then we use these recorded speech signals to extract features like MFCC and apply them as input to various machine learning algorithms to predict what is the heart rate of the individual. So with these algorithms, we got a reasonably high accuracy using the boosted decision tree algorithm. So which is 94% is a reasonably high accuracy, for being able to detect the heart rate of the individual just by analyzing the speech features. So the measured heart rate and the estimated heart rate or the predicted heart rate have a very close match of 94%. So this gives us a meaningful result that heart rate can indeed be measured from speech features like MFCC features. Similarly, we also did a study on the classification on the heart rate as being normal or abnormal heart rate. So typically, the normal heart rate of healthy individuals is in the range of 60 to 100. If it is below 60 or above 100, it is classified as abnormal heart rate. So again, by using the speech recordings, we analyzed the speech characteristics, which is MFCC characteristics, and you applied it to the classification algorithms and got very high accuracy. In fact, for the boosted decision tree, we got 100% classification accuracy. That means the algorithm is able to correctly identify that the heart rate of that individual is normal or abnormal just by analyzing the speech features. So it is quite promising in that sense. And more recently, we have been working on being able to detect COVID-19 from the speech of an individual. And again, what we did here is we tried to correlate the symptoms of the COVID-19 with various parameters of the human body, how these symptoms are correlated with various physiological parameters of the human body, and thereby associate that with speech. So therefore, if we can measure any of these parameters from speech, then we should be able to identify changes in these parameters which can occur because of the COVID-19 symptoms. So based on this, we performed some study and used the classification to determine whether a person is having COVID-19 or not. And with a relatively small data set, we got an accuracy of around 70%. So again, 70% is not good enough, but it is quite promising given that we had only a small data set available with us, because one of the challenges was to get the speech recordings of COVID positive individuals who have very strong symptoms. So getting the recordings of such individuals was quite challenging. So we ended up with a relatively small and unbalanced data set. And based on that, we could still get an accuracy of about 70% in classifying the speech as coming from a COVID positive individual or COVID negative individual. So it is quite promising that we are able to detect COVID-19 from speech. And again, one of our articles in this regard is published in IEEE Spectrum. Of course, it requires more work with large data sets to improve the accuracy and to actually have it as an app approved by the regulatory bodies to monitor this. So it's not just restricted to COVID-19. There are various aspects of the human body that can be monitored and diagnosed by analyzing human speech. So it's quite a promising field of study, which will facilitate and improve healthcare applications. Okay, and as I mentioned earlier, one of the challenges that we faced is in the collection of data, especially for COVID positive individuals. And another aspect of speech features, like previously we have used MFCC and STFT coefficients as the speech features for analysis. But here we are also exploring about another set of features called intrinsic mode functions, which also have very interesting properties like what we call as AM/FM effects. If you look at these waveforms, they are amplitude modulated as well as frequency modulated. There's AM and FM modulation involved in these signals. So basically, these have been extracted from human speech signals by performing a process called as empirical mode decomposition. And clearly, there are some AM/FM effects in these signals, in these IMFs. And why these are interesting is because the functions of our heart have natural AM/FM effects. So if you look at our ECG signal, the heart signal, right, it has AM/FM effects. So there is a reasonable guess that these variations of the speech can have a direct correlation with the performance of the heart or the conditions of the heart. So we want to be able to identify certain conditions of the heart by analyzing the human speech. And for that purpose, we are working on these intrinsic mode functions. But again, there is a challenge here. The challenge is that these signal components are quite large. These are vectors of like 50,000 length. So we need to process large vectors to analyze these signals. So that's a challenge, but again, that is something we are working on. So to summarize all of this, machine learning as a tool to address medical applications is quite promising, and we can approach this in two ways. There are AI experts who develop those algorithms and come up with new algorithms, or we can be applied engineers where we can use existing algorithms as tools for our purposes. So most of us will come into that category. So we will be just using existing tools, existing algorithms as tools for our purposes and applications. So it's quite promising. And given that it is possible to have a large amount of data collected over time, even if it is not available, machine learning and deep learning, these are promising tools for a variety of applications in healthcare. So we need to really focus on these tools in the contemporary era. So the saying goes like, it is a promising and fascinating journey to be working on machine learning. So jump on it and grab the opportunity when the time is still right. So because there is a lot of opportunity and a lot of applications can be created, and it is not just solving an engineering problem or a medical problem. It can benefit society at large if we can improve healthcare by being able to monitor individuals on a continuous and regular basis. So to summarize, we have seen that speech can indeed be used as a biomedical signal, and there are various biomedical parameters of the human body that can be accurately measured using speech, and it has the advantage of being non-invasive and does not require any contact with the human body. And the smartphone, can also become a medical device, and since it's available with just about everyone and just about everywhere, it is a huge advantage if we can use speech as a biomedical signal. And with the advent of machine learning and deep learning, it can make our diagnosis and treatment even more accurate and even more meaningful and improve healthcare. So that's it. And so clearly, I hope I have provided some motivation as to how speech can be used as a biomedical signal for healthcare applications and how AI can play a role in this. And I look forward to taking any questions that you might have. Thank you all. And I've taken like 10 minutes extra.
No issues, sir. Thank you very much, sir. Thank you very much for providing the remarkable speech on healthcare, sir. Speech as a biomedical signal. As sir discussed that about the biomedical signal for diagnosis the purpose with the aid of artificial intelligence. So sir has discussed what is the role of artificial intelligence to diagnose the patients. So I hope that this speech will definitely help the researchers and the authors who are working in this field. And sir, your topic was very much interesting because it is related to the social impact, has a very social impact. If we detect the problems of human beings early, so we can cure them. So I hope this will impact a lot for the researchers also and for the society also. Thank you very much, sir. Now I would like to ask the participant if you have any questions. Sir is happy to share the answer. Please ask a question too. You can raise your hand. I will unmute you.
Excuse me, sir. Can you hear me?
Yes, madam. I can hear you.
Yes, I can.
Good afternoon, sir.
Good afternoon.
It was really nice session. I have small doubts, sir, actually. Speech as biomedical signal, this topic, I'm like, if we implement this kind of thing in the machine learning, don't you think that this is going to take a lot of time to train the machine as well as the implementation also kind of, I mean, accuracy, how far you can achieve the
Right, as I've said in some of my earlier slides, for example, there are various aspects of measuring various biomedical parameters that can be done with speech. Of course, it's an ongoing field. We have worked on measuring the heart rate from speech. And the accuracy is like 94% with one of the machine learning algorithms, and the classification accuracy is like 100%. And there are other researchers who have published literature on this with reasonably high accuracy of their models. So accuracy is not an issue. Of course, we can develop models which are highly accurate, provided we have large data sets. But even with limited data sets, the accuracy is quite high, which makes it promising to use machine learning for such kind of applications. So the only challenge is about the collection of data, because there are a lot of speech databases available for speech recognition, and so on. But for biomedical purposes, what we need is not just the speech recording, but we also need, along with the speech recording, we need the biomedical parameters of the individual at that moment when that speech was recorded. So we need to correlate the speech with the measured biomedical parameters. And once we have that data, we can develop the AI models, which can have reasonably high accuracy, and existing results clearly suggest that the accuracy can indeed be very high. Coming to the complexity aspect, that the algorithm or the model can take a lot of time to be implemented or to be modeled. of course, it is some of the algorithms are computationally intensive, but as I talked in one of the slides where I talked about the enabling factors for machine learning, we have very high computational power nowadays. So we have powerful GPUs and farms of GPUs available at our disposal, which can speed up the training process and the model building process. And once the model has been built, for the testing phase or for the usage phase, there is no need for those extensive computational algorithms or computations. So only the modeling aspect requires intensive computation, and processing capability is available nowadays to have that kind of computation. As I said, with the GPU farms, which are available, for access, of course, for subscription, where we have to pay, and for a limited scenario, we can access those GPU farms for free as well. There are platforms which provide access to GPUs or even GPU farms to process the huge amount of data and to build those complex models. So it is indeed possible, and it is indeed having reasonably high accuracy. Of course, there is research ongoing to improve the accuracy of those models.
Okay, sir. I just wanted to extend this question. Can you suggest any kind of CNN model that can be used for this kind of implementations? Like, for example, we have UNet for medical image processing with brain tumors and all. We can go with the UNet model. Like that, can you suggest any type of CNN? Well,
I can't name any specific model. Okay, I'm not aware of any specific model that can be used for it. But what we have used is there are models on the Azure platform, the Microsoft Azure platform, which we have used.
Okay.
And we have these algorithms like the boosted decision tree and so on. So these are state-of-the-art algorithms which are available. So we have used these existing algorithms for our purposes. And since we are using speech and speech features as vectors, we have to use those algorithms which are taking input signals or input features as tables, not as images. So that's a clear distinction we need to have here. There are algorithms which take in images and process those images, but here we are not using images as our input signals or features, but rather we are using a table of labeled data which has sets of features and an outcome which is being mapped to those features.
So that means like the speech will be converted into text and it will be built like a table and then it gets used by the decision trees, something like that?
No, it is not converted to text. For example, I talked about MFCC features, right? Or STFT features. So by performing signal processing, right, we calculate what we call as the STFT coefficients or the MFCC coefficients. These are basically numbers. So it will give us a matrix of, say, 20 features into 20,000 rows, right? So we can have like 20,000 rows and 20 columns. So it will be a matrix of matrix data, which is having numbers basically. And these numbers are basically representing some feature of speech at that particular instant of time and in a specific frequency value. For example, our human speech is having a frequency range from 0 to 4 kilohertz. But when we are talking, when we are making a sentence, at any instant of time, there are only certain frequencies present and with a certain intensity. And at a different time, there will be a different set of frequencies with a different intensity. So there is a variation of the temporal characteristics as well as the frequency characteristics. So by performing these signal processing, we can extract these features like MFCC or STFT or the empirical mode decomposition. So these are not text files. These are a matrix of numbers, but these numbers have some connotation in terms of the temporal value at that time instant and the spectral value, that means the frequency content of the signal. So these are temporal spectral features of the human body, of the human speech, which are generated as a matrix, and this matrix is fed in as input to the machine learning algorithm, which will develop the model. And again, the whole idea is that we want to map our human auditory system, because when I'm speaking and if you're listening to me, by listening to my voice, you can gauge certain characteristics about me, about my emotion and so on, right? So our human brain is being able to process our sound and able to come to certain conclusions. Similarly, we need to identify feature sets which can mimic the human auditory system. So MFCC is one such system. Male frequency section coefficients, which I talked about earlier, is a model, not a machine learning model, but a signal processing model that kind of mimics the human auditory system. Just as we are able to understand certain things about a person's status by listening to their sound, the MFCC is trying to capture that information. So we are using that information as input features to the machine learning algorithm and try to map it with certain characteristics of the human body.
Okay, sir. Thank you, sir.
Welcome.
Thank you so much, sir. I hope you have satisfied, madam. Sir has given a deep description of the question.
Yes, sir. Actually, that was really interesting.
Yeah. So thank you, sir. And we are looking forward to have you in our future conferences as a keynote speaker. We are very thankful to you, sir. You have given a very good speech regarding this speech signals in the role of AI/ML, artificial machine learning. Thank you very much, sir.
You're welcome. Thank you. Indeed, my pleasure. Thank you.
Thank you, sir. Thank you, right, sir. Swati, madam. Can you hear me, Swati, madam?
Yes, sir. Yes, sir.
Madam, we can start our panel session 2.
Okay.
Yeah. It is.
Good afternoon, everybody. We are glad to have the second session chairs here. Dr. Ranjit V. Ravi from MBA Engineering College, Malappuram, Kerala. Dr. M. Sujitra Ma'am from Coimbatore Institute of Technology, Tamil Nadu. And Professor Adesh Pandey from Uttar Pradesh, India. We welcome you, sir. Sir, can you hear us?
Yes, ma'am. Yes, thank you.
Thank you, ma'am. With your permission, shall we start the session, sir? Session, ma'am? Yes, ma'am. Okay. I would like to call upon paper ID 30. The author name is Sai Shri S. Can you hear me? S. Sai Shri?
Yeah, she's in the meeting, madam.
Sai Shri. Sai Shri, can you hear me? Sir, shall we proceed with the second paper ID otherwise?
Yeah, we can proceed to 34.
Okay. May I call upon P. Y. Ramadevi or Pannalal B? Paper ID 34.
Pannalal Boda, yes.
Hello. Pannalal. Sai Shri, ma'am. Are you here?
Yes, I can hear, ma'am.
Okay. Ma'am, can you share your screen?
Yes.
Actually, you have 12 minutes for presentation, 2 minutes for question answers, right?
Yes.
Yeah, finish your
Please wind up in the stipulated time, ma'am, because we are already running out of time.
Yes, ma'am. Yes.
Thank you.
Can you?
Yeah, we can see the screen. Please turn on the slideshow, ma'am.
Yes. I have turned on, ma'am.
Yeah, that's done, ma'am. That's done.
Yes. Good afternoon to one and all. I'm presenting a title of a comprehensive study on Eucalyptus, CloudStack, and OpenStack. And I'm the author one, Sai Shri Shungarappa, and the author two is Shiddat ES, and he's my guide. And the list of the contents are the introduction, analysis and result, and conclusion of the field work. In introduction, what is the meaning of the cloud computing and how it is benefited, and what are the users are being there in the cloud computing, we have discussed about it. And the cloud computing is the ecosystem and on-demand availability of the computer system resources, especially the capacity used for the data storage, data access, and the computing power without direct active management by the user. And cloud computing is the derivative of the computing resources, including data storage, distribution, networking, and software analytics and intelligence. These are the instruction of the cloud computing. And the benefits of the cloud computing is data security, low maintenance cost, excellent accessibility, services pay as per use, mobility, backup, restore data. In the cloud computing, not only the advantages being there, also disadvantages will also be there. Internet connectivity. Without the internet connectivity, cannot access any data, whichever the information we have stored. And vendor lock-in. In vendor lock-in, we can. It is the biggest disadvantages of the cloud computing. Organization may face some of the problems while transferring of the services from one vendor to the another vendor. And one more disadvantage is the limited control. As we know, the cloud infrastructure is completely maintained, managed, monitored by the service provider. So the cloud users have a less control for the function and execution of the services from the cloud infrastructure. It is the delivery of the computing resources as a service, meaning that the resources are owned and managed by the cloud provider rather than the end user. And cloud tools help to create a virtual pool of the resources. Benefit of it is a resource allocation, tracking, and billing. There are many of the cloud computing tools are introducing by the cloud. Some of the cloud tools are cloud middleware, Eucalyptus, CloudStack, OpenStack, Cloud Foundry, Google App Engine. Why the cloud tools are introducing in many manners? Developing of the cloud is ensure that the application can be released to the market very quickly. So the cloud tools are introducing in many manner. And some of the key issues that we have discussed is the differentiating cloud tools, that how much impact for the software tools is there in the industry. Like all other open source clouds, Eucalyptus contains a public community that contributes to platform improvement and helps in finding and fixing the bugs. Eucalyptus is the popular cloud platform, and it is an open source computer program framework in cloud computing, and that is utilized to implement the cluster within the cloud computing stage. And Eucalyptus has a free version and a commercial edition. One of the greatest advantages making this platform truly convenient to work with is that the Eucalyptus API is fully compatible with the Amazon API, can be easily employed for your private cloud. And Eucalyptus supports some of the hypervisors, Zen, KVM, and ESXi that we have discussed. And CloudStack has a few kinds of the highlights such as the storage, independent computers, and admins to make security zones overlook hills. OpenStack is an infrastructure as a service arrangement through a set of interrelated administrations. And the literature what is analyzing the performance of the three cloud platforms, Eucalyptus, CloudStack, and OpenStack. In the cloud tools, we have discussed the uses and the performance of the tools. In CloudStack and OpenStack, users are more than the Eucalyptus. And the community rate is also very huge in the CloudStack and the OpenStack. And the CloudStack, the community is higher than the OpenStack. In security purpose, Eucalyptus is very high and easy to deploy as a hybrid cloud. But both OpenStack and the CloudStack are similar in the architectures, but in OpenStack has a higher installation complexity. CloudStack can allow large network of virtual machines and also tends to provide the most common set of features that organization requires from an infrastructure as a service platform. And these are some of the differences that we have found from the OpenStack, CloudStack, and the Eucalyptus. And the cloud of OpenStack, CloudStack, Eucalyptus is going to be used as a public and a private. And the implementation of the cloud will be as a hybrid. And some of the API support. API is nothing but application programming interface. And these are the support that the OpenStack is going to be take from a native API, Amazon EC2 API, Cloud Files REST API, and the CloudStack API supports all Amazon EC2 API S3, and API support of Eucalyptus is Amazon EC2 API. And the methodologies of the eucalyptus serves the needs of the user, and the cloud stack better serves the needs of the developers, and OpenStack serves the needs of the vendors. Cloud tools have the technology base and marketing brand to build their own stack, and the cloud stack is a console for managing the data center computing resources. There are well-known information-driven companies such as Nokia Research Center and Cloud Central have deployed clouds using cloud stack. The OpenStack is a cloud system which manages the sizable pools of storage, networking resources, and servers around the data center. And this OpenStack is controlled within the central dashboard. And on the other hand, it is an open source application that is used to control the vast network applications. That analysis and the results. In comparison to other cloud platforms that in this inquire above, OpenStack appears to have the biggest and the foremost dynamic community. The community members are continuously willing to assist other discover arrangements to any emerging issues. There are online community ready to supply opportunity, specialized back without charge. You'll be able to discover arrangement to numerous cloud stack issue on the gathering. Typically, these cloud platforms are more beneficial for both cloud users as well as the organizational sectors using the cloud model because which delivers the advantages of easy maintenance, high security, adaptability, and reduced cost consumption. In the cloud is the main beneficiary is nothing but the cloud cost consumption is a more beneficial. And the conclusion of the eucalyptus is an possible choice for the private cloud providers. And the eucalyptus is the mainly used private cloud itself and research due to its extensibility and quick installation. And many of the companies have also chosen it to deploy their private clouds. They are the Sony, Puma, NASA, and Micro. These are the companies who have preferred to deploy their clouds in the eucalyptus. And OpenStack is the best choice for the public cloud providers due to its scalability. And also it is an open source application and it controls the vast network of the applications. Eucalyptus also makes a good option than a cloud stack, OpenStack. Cloud stack board is composing of multiple servers. So OpenStack needs to install separately to configure the projects. In the future, we want to make a deep analysis of these three cloud computing as a data scheduling and data applications in the cloud environment. Is there any queries? Hello.
So, okay, good afternoon. So, are you implemented this any API interface with this eucalyptus?
Sorry, sir, your voice is some clumsy. Can you repeat it again?
So, with this eucalyptus,
audible. Yes,
okay,
sir.
Okay. With this platform, are you implemented any work, any research work?
Actually, we were right now. We want to implement all the data scheduling and the data applications. Right now, we have compiled all the tools like the Eucalyptus Cloud Foundry. We have found some of the differences from this. We want to implement for the future work.
That's fine, but actually for this comparison, have you done any simulation or just referred papers and ideas only?
Yes, we have referred some of the papers, and also we have gone through with the installation things of a VMware, and we found some differences in this. So,
okay.
Yes, sir.
But for an effective comparison, I think some kind of installation is required, implementation is required, right?
Yes, sir. For the data scheduling, we need to have a quite possible things to be implemented for furtherly. So we are doing right now that the future work we needs to do in a manner.
Okay, but one suggestion from my side is actually one thing is your slides are a lot of crowded.
Yes,
so something crowded is there. Most of the slides are like so. So that should be some space should be inserted in between the points to show it clearly. And also that's one thing. And also one, if you told that you have taken ideas from the different papers. So in the slide itself, you can do citation for those papers. Okay, so that will be also good.
Okay, sir.
So kindly note this points and
Yes,
in your
sir.
future presentations, please consider this.
Yes, finally, sir has rightly pointed out the points. Your repeating them not as the proper format, and if you are citing some, you are writing some research work, you have to cite them, right?
Yes, sir.
Yeah,
For sure.
in your future research, you please implement those things. Just make a note of it.
Yes, sir. I have noted it. Thank you, sir.
And one more thing.
Yeah.
So since we are comparing the networks, cloud, even you have compared public, private, all together, but you have to take care about the matrices, storage, security. So these all plays a vital role.
Yes,
So
sir.
you have to take care of those aspects also.
Yes, sir.
How far secure, how you are storing your data, how it is you have only taken care about the private, public scalability, that's it. But you have to see how far you are secure your data is and how efficiently you are retrieving your data from the cloud. All those steps you have to take care and you have to add future references also.
Yes, sir.
So since we are in 2022, you have to add the references.
Yes,
If it is survey paper, if it is survey part plays a vital role. Then you have to have the matrices, what are the matrices followed and what's the threshold to choose the network. That is from my side.
Right. Any other questions from the session chairs? Okay, so we are in short of time actually because first keynote was a little long. So now Fatima,
I'll go with the next paper ID 34. Panala Boda, sir, are you here?
Yes, ma'am. Yeah, Panala, sir, you can share your screen. Science, you stop sharing.
Please stop sharing your screen.
Yes, ma'am. Yes, ma'am.
Science, you can stop your sharing.
Panala, sir, please share your screen.
Hello.
Sir, we can hear you, sir.
Yeah, we can hear you. Please go ahead.
Hello.
Sir, we can hear you.
Hello.
Panala, sir, we can hear you.
Sir, we can hear you. Panala, sir, we can hear you.
Hello. Yeah, sure, sir.
Right. You share your screen.
I'm sharing, sir. I'm sharing.
Yeah. Okay. Right.
Yeah, yeah.
So your screen is getting shared, but please share your PPT.
Yeah, yeah, sure, sir. Hello?
Sir, we can hear you, sir. Please go on.
No, it's not right. Madam. Wait.
I guess you just downloaded it, sir.
No, already I downloaded, madam. Hello?
Sir, is your presentation ready?
Hello?
Sir, we can hear you. Is your presentation ready?
Sharing it out here.
Sir, we can already see your screen. Sir, we are able to see your screen. Please open your PPT.
Yeah, wait, madam, just a minute.
All of please keep reading the PPTs. Madam, I think we can call the next participants.
Okay, sir.
30.
Call upon paper ID 37. Deepan Girish.
Yeah, I'm here in the I'm just sharing.
Okay, sir, please share your screen.
Hello?
Yes, Anurag, sir, you can present after this.
Yeah, sure, sir, sure.
Please keep ready your presentation. Open your
Yeah, sure, sir, sure, sir.
Yes. So it's not visible?
Yes, sir. Girish, sir, it is visible. Please go on.
Yeah, okay. Good afternoon, all. So welcome to this presentation of crop disease auto-localization and classification. So before I begin, I just want to give a shout out to ICAIDS for giving us this opportunity. And secondly, I would like to thank my team, Aditya Verma, Tarun Raj, and Shivani Bish, who were immense parts of the success of this project. And I would also like to thank my guide, Jyoti R, for her mentoring and guidance. So as you can see in this slide, so our project is consisting on, it depends on the the agricultural sector aspect. So as you can see in this slide, contribution of agricultural sector towards economic growth. So there has been a paradigm shift. So we are showing here a PPT where this is taken from the Ministry of Statistics and Program Implementation. So here you can see that agriculture constitutes a considerable amount of the economy. So it is a major industry and foundation of the economy. And now AI is steadily emerging as a part of its technological evolution. So now one of the applications that we will see in this project is crop and soil health monitoring. And now coming to the crux of the problem statement. So here you can see two images. So on the left, you can see rice production and productivity in India as of 2011 and 12. So here you can ask two questions. Number one is why rice? And number one, why do we have to do anything with data which is a decade old? So there are, the reasons are due to being the production of rice. If you see our data from visualize.data.org, which is the government website, you can see that rice production has, in fact, from 2011 to 2016, in fact, has quite plateaued or in fact decreased. So the reason for this being is that plant diseases, natural factors, and pests. So in this, you're seeing a state-wise level breakup of rice production and rice yield. So here you can see that states like Uttar Pradesh, despite having a lot of production, are just above average rice yields. So trying to get maximum yield through say crop disease or localization, performing these crop and soil health monitoring is quite vital. So here, where do we stand compared to say rest of the world? So here, that is, you can see that we are pretty much at the lower end of the spectrum. So this is not where we intend to be with so much rice, with the rice being a stable diet. So now coming to the types of diseases that are normally seen. So this images was from a research paper that we actually went about, and also we were able to gather a lot of information about these kinds of plant pathology information through UIS or Universal Agricultural Sciences, which is a premium agricultural institute in Karnataka. So as you can see here, you have a lot of spots, and these are different kinds of diseases that can affect a rice crop in particular. It can be bacterial, viral, or fungal. So now, what was the difference that we draw from the literature survey? Number one, the image classification. So they were using traditional algorithms like genetic algorithms, they were genetic algorithms, or using decision trees and k-means. So what are the issues with using these kinds of algorithms is that you have challenges of computation, issues with robustness and quality requirements. So what do I mean by computation here means that you need a lot of computational effort, and robustness being that you can't replicate this, say, to large scale data. And quality requirements being in order to do modeling training itself, you have to pre-process the image a lot. So you have to be working on the image a lot in order to just feed into the model. And then coming to the performance of ML and DL models, existing literature survey showed that ML and DL models were kind of successful, were achieving state-of-the-art accuracy. And then coming to the segmentation part, hyperspectral imaging was quite successful. So the reason it was quite successful was that, first of all, that it's a non-invasive process. So non-invasive process where plants are actually scanned for collecting data. So existing literature surveys in previous surveys, what they did was they would take a sample of stem of the leaf, and then you biologically use indicators and then study under the microscope. So that's a very elaborate method, very long method. So this is where hyperspectral imaging actually made a significant breakthrough, and you can see that it provides a lot of high resolution images, and it has been pretty much a mainstay for a lot of images research over the last 5 years. And then coming next is limited research on auto-localization fields. So we've only seen image classification being performed. What next? What are we doing beyond that? Just classifying is not enough. So we felt that there was less research on auto-localization of these. And then again, lack of credible open source agricultural data sets. So there are no data sets pretty much at all if you see where you could do open source, where you could just do it at the convenience of your say home.
And then images were not representative of the real world. So this was because the number one is acquired through high resolution cameras. And then, as I mentioned earlier, the extensively processed using noise removal, color space conversion, contrast, improvement, brightness correction. So when we face this issue is, say you want to replicate this application in real world. So now when we use, say, as farmers, or as when we use, say, a smartphone camera, it's actually not representative of real data. So that is where you might get underfitting, or that is where you encounter problems where the model is not working. So we try to address all these drawbacks in our project. So what are the implementation details? So we divided our project into, say, specific modules, as you can see. So number one was data collection and augmentation. So we scraped some images through the net or internet, and then we performed, say, some sort of image processing and augmentation so that it is as realistic as possible. Then data set preparation. So we processed, say, worked on, say, converting everything into a CSV format where we could actually work it out. So that comes with the data set preparation. And then we have image annotation and segmentation, where, so now this aspect, image annotation and segmentation, so this is for the bounding box regression that we actually intended to do. So this bounding box regression, that is for the localization, which we, here, the localization which we wanted to address. So this we did it using label ID, so we manually annotated data. So coming to segmentation, so we wanted to use a novel method. So this is where we used medical imaging for image segmentation using the diagram format. So we felt this was a novel method.
So there are only 4 minutes left for you.
Yeah, almost done. So as I was saying, so medical imaging, we felt kind of replicates hyperspectral imaging. It was quite successful. And in our project, we did found that it was quite really helpful. And then we did classification, monitoring, and validation. We performed CAD-CAM visualization for validating data, seeing whether our model is actually looking at the places where it needs to be looking. And then we did model analysis, bounding box regression.